to NARC Live on Wednesday the 17th of November 2021, coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G0MQG. Good to see you. You'll see why we're a little bit flummoxed in a moment. Firstly, on tonight's show, we have live with us someone here. It's Tony, G0MQG. That's a still picture, but he really is here. Bob G6PWS shares wonderful pictures of these hawks. And we find out what on earth is this? Had lots of entries this week. Must admit, a lot of people have seemed to know what it is. If you haven't entered and you want to have a quick entry now, you can do on Facebook or on BATC. But first, I hope you can hear me, by the way, because I can't hear myself in my ear.
The trouble is, I think
Okay.
we've got microphone issues.
Have we?
Cutting in and out.
Right, okay. Well, we're going to have to sort that, and we will, I'm sure. Just to let you know, one of the reasons is we've set a sort of another studio up just beyond where you can see us, and it's been a bit of a rush to do that. So just bear with us. We'll sort out the audio hopefully later. Hopefully people can hear me because I can't hear myself in my ear.
You're picking up on my microphone.
Am I? Okay, lovely. Okay, we'll have to get close, dear.
Yeah.
Like we're married.
Yeah.
We are. Oh, all right. Okay then. So let's have a look at some of the things that you've sent us this week. Thank you very much. So Donard M0KRK has sent us this, and he says, I've just returned from the event in Dublin where the Valencia World Heritage Technical Report printed version had its formal launch in Trinity College, and it can be watched at another address. And here, I think we've got some issues here, but never mind. This is the sort of pictures he thought Tammy and I would like to see these pictures, and you, about all the technical equipment and everything that's there. So there we are. That's all the equipment that was there. Now, if you want to have a look at the full video where Donald actually gives a presentation, you can have a look at this. I think if we can get this up. This is a bit complicated for Tammy now because she's got to swap between various inputs because we have a lot more cameras here than we normally do on a night like this. Let's see if Tammy can just share that now with your screen. And we'll put the link of this, which will be much better, I think, for you at home. We'll put this on our newsletter and you'll be able to watch this fully for yourself. But this is the sort of thing that you'll see.
Brendan's grandfather, I believe it was his grandfather, was the 4th superintendent at Valencia. But Brendan one time told me about his father, who worked for Western Union in London, and mentioned that his father had come home on one occasion and said to his mother, Churchill was in again today, the Western Union officers.
Anyway, you get the idea. Don't want to interrupt you, but it's an hour's programme, or an hour's film rather, so it would be unfair to take it out of perspective. But we'll put that on there. If you are experiencing technical problems, we believe there might be some problems on the BATC tonight, which is unusual. So if there are, you can hop over to Facebook or vice versa.
I think we're recovering on BATC.
Good, okay.
At the moment, we were buffering a little bit to start with, but
there's no real, there's no rhyme or reason why this happens. Sometimes we use the same internet connection for both, but sometimes there's an issue either at Facebook or BATC, or possibly here, but it's unlikely if they're both, if one of them is okay. Anyway, we will stumble on. Hopefully you can still hear me. Now, Bob G6PWS has sent us these pictures of a pair of hawks, and here we go.
sorry,
It's all right, Tammy.
I'm having issues.
I know, there's an awful lot been going on. Here we go. So these are some of the pictures that Bob has sent us. If you could see the screens in here tonight. Anyway, look at this. This is a pair of hawks and pictures that Bob took himself, including one driving off a seagull over their nesting site. And this is in the Hatfield House estate.
Lovely pictures, aren't they?
Yeah.
Get that up.
You've got to be quick because they'll be moving quickly, aren't they?
They will. There we go. Lovely. Thank
Brilliant.
you, Bob.
Thank you very much, Bob, for sending us those. We're close up and personal to try and share the mic because we've got wireless mics that we're going to use elsewhere tonight. Anyway, the final thing comes from John 2E0TWQ. Now he says, this is what Roger said, John said, Roger D3LEI and the CW members will love this one. Perhaps they could add it to their lessons. Well, actually, I think this is rare CCTV footage of the last Morse boot camp that was held at Rogers. And Tammy, I don't know if you're ready to show it. So let's have a look at this.
Short wave, take it down, quick. What's it say? Ah, shut up. What'd that mean? You too?
Thank you very much. That was on YouTube, I believe. So
It was.
Thanks for copyright and everything else. So thank you very much, John, for sending us that. Which one was Roger? Do you think it was the one who was slapping the faces?
Probably, yeah.
Not paying attention. Right, anyway, thanks very much for sending us those things. If you've got any news for us, we'd love to hear from you, of course, every week. Send them to radio@dcpmicro.com. radio@dcpmicro.com. If you can get it to us by Wednesday, 3 o'clock at the absolute latest, but ideally a bit before that, because we have to put these things sort of together. Now, I don't even know if you've had time to do a Little People.
I did do Little People.
Have you? Okay,
Yeah.
Tammy. Well, I don't see this before you do at home. So here's tonight's Tammy's Little People.
This was just called a delivery hub.
Oh, I like it. That's great. That's a kind of internet hub, isn't it?
Yep.
With some lorries. Miniature-calendar.com.
I say, I hope they're not actually putting those little bits in there.
Oh no, do you reckon that's what... Oh, let's see.
Or taking them out.
They're just putting the RJ45 Cat 5 connectors in there.
Yeah.
Brilliant. It is good though, isn't it? It's simple. You can do that with a couple of model cars and a router. Miniature-calendar.com. Thank you. So I said, please keep in touch, and we're now to that point in the programme where we're going to have a look at that mystery object that we posted last week. And we said, as we do every week now, what on earth is this? Now, we did have quite a few guesses. Have we got anybody online guessing who this is?
I haven't looked, to be honest. Let me have a quick look. You start reading it. I
Okay.
don't think we have.
All right, okay. Well, okay, here we go. The first, I'm reading them in the order that they came in, by the way. So the first was from Kev M0KKM. He says, the latest object looks like a nice homebrew variable capacitor. As it's fitted with a nice motor, I guess it's part of a magnetic loop. Or maybe it's the prototype flux capacitor that Doc fitted to a Land Rover. I thought it was a DeLorean.
Yeah.
Anyway, a Land Rover, he said, before he discovered that he could not reach 88 miles per hour.
Oh, maybe he's just saying he can't get 88 miles
Well,
an hour
that's
in a Land Rover.
You wouldn't, would you? Tom G8XQD says, this is what to do when they stop making variable capacitors. Is it a homebrew VHF remote antenna tuning capacitor? Neil G4JUV says, motorized variable capacitor. I'd expect to see this tuning a small magnetic loop antenna, perhaps a remote ATU. Bob G8STU says, I think it's a high voltage motorized tuning capacitor. Now, this is something a bit different. Nev M0NFY says, I was tempted to say that it was a sewing machine. If he does this enough times.
It might be a sewing machine one week.
But then I zoomed in on the picture and saw the motor and sandwich PCB. So first I thought it was a 23 centimetre butterfly antenna, but a closer look makes me think it's a variable capacitor where the motor rotates the sandwiched PCB, possibly used as part of a mag loop setup. Colin at M0GMK says, I think this week's mystery object is a remote-controlled variable butterfly capacitor, probably used for tuning a magnetic loop antenna. Out of interest, what's the capacitive range and safe working voltage? Well, Colin, if you're right, maybe the person who gave us that will be able to tell us, but that's assuming you're right, of course. John M6JAU says, I've never seen one of these, but I reckon it's a motorised adjustable capacitor, presumably related to an amateur radio purpose. I see a fixed PCB with 2 copper sectors and a rotating PCB also with a sector design. So a motor gearbox rotates this plate so that sectors overlap with those on the fixed board by a variable amount that varies the capacitance. Given the size of the air gaps, the capacitor will be quite small. Capacitance will be quite small. Mike GEY says this week's item is a motor-driven variable butterfly capacitor, typically used to remote tune a magnetic loop antenna. The split stator avoids the motor drive being at a high RF potential and maintains the mag loop symmetry. Tony M0TDK says this week's mystery object looks like a homebrew electrostatic generator. It's hard to tell from the picture because I can't see between the two layers, but I think it may be a Wimshurst machine. Alternatively, it may just be a very large capacitor which appears to be attached to a windscreen wiper motor. Martin G3ZQU says, I think the item is a homebrewed variable capacitor for tuning a magnetic loop. The top plate is fixed and the plate underneath is rotated by the stepper motor mounted on the base plate. Paul G3VPT says, I think it may be a test beacon of some sort feeding the 70 SEMS bow tie antenna on the top. That's one of the few different answers we got. Simon M0SIH says the object shown on What on Earth is a homebrew variable capacitor. It looks like the copper-clad board vanes are moved in between each other with a servo motor to alter the capacitance. It may have been used on a loop antenna. Love the show, he says. John G8VPE, I would guess that it's a homebrewed motorized variable capacitor, possibly used to tune a magnetic loop antenna. And finally, last but not least, David G3VSJ says, David, I think that it might be a remote controlled variable capacitor. An interesting discussion last week via about ICNERP. I've managed to do mine. Keep up the good work. And after all of those answers,
We've had a couple of extra answers.
okay,
So Paul, I can't remember what his call sign is. M1
AFQ.
FQ says a frequency counter or a tuner.
Okay, tuner, maybe.
And then
sort of.
John T0TWQ says, is it a remote control bow tie?
Right, and Paul says there, dot.
And then Ricardo De Ponte says, is it a George Foreman grill?
A George Foreman grill, that would be nice. And since I haven't had my meal yet, that's making me feel hungry. Anyway, we better reveal what it is. And it was a poor man's remotely tuned capacitor for tuning a loft-mounted 630 meter loop. I doubt it was 330 meters. Anyway, the geared 12-volt motor turns at 2 RPM, really slow that is, and moves the butterfly-style rotor between two fixed plates. And that was sent to us by John, G8CHP. John, if you're watching and you know the voltage rating of that and the capacitance, I think it was Colin who'd be very interested to know. Anyway, thank you very much for all those entries. It was unlike last week. We had lots of entries, but they were all very diverse. This week, most people got the fact that it was a variable capacitor. So it was testing your electronics knowledge. So having done that with you this week, let's have a look at last week. Let's have a look at this week's What on Earth is This? Now, the person who sent this made me have a guess before they told me what it was. And I'll just say I didn't get it right.
Well, I must admit, there was another picture, but I thought that was probably the answer.
Exactly,
so
you
I
mustn't
didn't
show
put it
that.
on.
No, no. So you know.
Oh,
Okay.
I don't actually. I didn't look at it.
It's unusual. Have a look at that. Have a close look. The shape of it and everything. Have a think what that could be used for. It's fair to say it's an everyday object, not necessarily for radio amateurs, although they might want to use one. And let us have your answers by 3 o'clock next Wednesday at the very latest to radio@dcpmicro.com, and then next Wednesday on NARC Live we'll reveal exactly what that was. Is my mic working now, by the way?
No, I don't think so.
Okay, great. All right. Okay, so there we are. That's this week's object. We'll put that on Facebook and we'll put it on the newsletter and on our website as well for then. So next week at Norfolk Amateur Radio Club, just to tell you what's coming up before we get on to tonight's programme, I hope we're going to have sound, or we're going to be an awful lot.
I think we might actually have a bit of sound.
All right, next week at NARC, so it's Sunday at 7 o'clock, it's the GB2RS News on GB3MB. On Monday the 22nd of November, we've got the Monday Night Net at 7:30. This week's host is John M0VCX. And at 8:30, the 80 metre CW net on 3.543 megahertz. And next Wednesday, the 24th of November, can't believe November's nearly gone now, we've got this crew. It's the Demolition Crew. Sunny M0SYW and Paul G4ZBA. They're going to be here. Not be here, actually. They're going to be there where they are. They're going to be there. But they're going to give us the behind-the-scenes info on what they do with their demolition crew. You've seen videos and pictures of them and all their escapades, and we thought we could persuade them maybe to give us a sort of talk on the sort of thing they've done, the sort of things they've learned, I'm sure, by helping lots and lots of people. So Paul and Sunny will be revealing all and their demolition crew next Wednesday on NARC Live. And as usual as well, just to mention this card, this is the NARC card. I think we sent one this week. To anybody that you feel will be cheered by a card from your club, just drop us a line with their name and address, and we'll add your name to ours and send it to them. It's radio@dcpmicro.com. Also, your stories and things like that. Please let us know what you're getting up to. So it gives us a good bit of news to start the show with every week.
It'll be Christmas light season soon, won't it?
Will it?
Yeah.
We're not mentioning that, are we?
Well, no, but then people have cool Christmas lights, don't they?
Oh, okay. Well, yeah, we could do that.
Yeah.
We shouldn't be encouraging them to put... You put a little Christmas tree up here. A little USB Christmas tree up here at work the other day. I was horrified.
Well, it's so you'd know if you left the computer on
Well,
overnight.
yeah.
And then what did you do? You left the computer on
Yeah,
overnight.
okay, all right. It's a domestic. All right. Anyway, tonight, what it's all about is about fixing things. I don't know if you've ever had a go at fixing things. It's... you don't just need electronic knowledge. You really need a little bit of a strategy, really, I think. And we've got the most well-known, I guess, Mr. Fix-It here with us tonight, Tony G0MQG. So while I unclip myself and unmic myself, and hopefully you'll be able to hear me, I'm going to go over there and meet Tony. Tammy's going to show us a picture of him and hopefully be able to hear him, and I'll make my way over there. All right, so we'll see you very shortly.
Hello, Tony.
Hi, everybody.
We can hear you.
They
Excellent.
can hear you,
wonderful.
but not me.
No, I think we can hear you
Everything's
as
working good.
Right, I shall make my way over.
well. You make your way over.
You can hear me now, can you?
Yeah, I think so.
Why can you hear me when you're sitting down there? You'll have to explain that to me. Anyway, Tony, welcome to NARC Live. It doesn't
you.
seem possible that it was a year ago, does it?
No, time flies.
I mean, and I remember this time last year as well, we were... Oh, you can't see my face, so I'll have to get down a bit lower. We did do this in a bit of a hurry, as you can see. We had a lot of things to do. I mean, we were wearing masks then, of course, as well. So although we may think, well, I can't believe it's a year, like I said, but at least we've, I suppose, progressed a little bit. We don't have to wear a mask indoors, even though I'm sure we keep socially distanced and everything else. So
Yeah, you
tonight,
still have to be so careful.
oh yeah, absolutely, definitely, absolutely. But it's good that you're going to be here. We've got a little camera which will be able to show some close-ups and things. And tonight, I believe the first thing you're going to show us how to tackle is power supplies. And of course, whatever we do in the hobby, pretty much whatever band we're on or anything, we're going to need a power supply.
That's right, yeah.
So show us what we've got here, and I'll grab a little camera.
Right, well, the first one I'll show you is this one. I'll point the front towards David's camera so you can see what it is.
Right, let me just, actually, Tammy's going to need to...
Can you just pull your pack out of your pocket?
Yeah, sure. Okay. Right, hang on, I'm just going to do something now. Right, I've got a little wireless mic pack here. Is there a problem with that, Tammy?
It keeps cutting out a little bit, but we'll
Does it?
see what we can
Okay,
do.
we'll see what we can do then.
You speak
I'll
loud,
tell you what
you'll
I'll
hear
do.
it,
I'll tell you what I'll
you'll-
do. I'll do what Tony's done, this little mic pack, and I'll actually clip it on here. Let's try about this little commercial break. There we are. Now can you hear that now? Better.
Yeah.
Right. I'll put the wires in my pocket and hope that I don't forget them before I go to bed. Okay, Tony, so back to this. So you're going to show us tonight a power supply. Now, hopefully Tammy can get this picture. I'll try and hold it still. There we go, Tammy.
Yeah, good. That's what I wanted to see.
Okay. So what
I-
have we got here, Tony?
Right, this is one of the best described as cheap and cheerful power supplies that we used on CB radios some time ago. I was given this one about 5 years ago in non-working order, and I suspect it had been overloaded. As you can see, it's a 5 amp. I suspect it had been overloaded because the pass transistor, the driver transistor that drives the pass transistor, the Zener Diode that provides the, regulates the output voltage, and the 4 rectifier diodes, you'll get to see all that in a moment, all of them had failed. And
is that what normally happens? Because I must admit, we must try and explain some of this, because although some people have electronic knowledge, others won't. So we've talked about a few things there. We've got the big heart of it, really, the thing that drops the voltage from the mains. Is it all right to have a look inside now?
Yes, of course.
Tony, do you think?
Yeah.
I mean, the big thing that does the job, and we often call it this sort of generic name, is a transformer, isn't it? So this big brute here takes mains in at one end, basically.
It is unplugged. That's the main side.
It is unplugged, isn't it?
Yes, it is, yeah.
Right, okay, good. So we've got the mains going in at one side, and it transforms that, drops the voltage, and gives us an output the other side.
Yeah, it steps it down to, I think it's about 18 volts. This particular one, the secondary winding, you'll notice there's 3 terminals, and the reason being they're centre tapped.
Right.
And the rectifier is what's called a biphase rectifier. You'll get to see the schematic in a moment. And the rectifier diodes.
So let's have a look. So they're those things here, aren't they?
Yeah. The rectifier diodes are these devices here. Still got to get used to looking at the camera while I'm...
Yeah, that's okay.
Yeah.
Well, don't worry about that. If you look at just the devices,
Anyway.
I'll follow those, Tony.
Yeah.
So we've got there 4 diodes, haven't we? And that's
Yeah.
what makes up what's called a bridge rectifier?
No, it's a biphase rectifier.
Oh, is it? Okay,
Yeah,
I beg your pardon. Right, well, let's have a look at the circuit diagram now.
Yeah. The diodes are actually 1N5402s, 2 in parallel on each side.
Okay, that's an unusual
So,
one. Why
yeah.
would they do that? Is that to increase the power?
It's to
capability?
increase the current. They could have used 6 amp diodes, so I'm not exactly sure why they've done that. But
Right,
there's a
but they're
reason
3
that's
amp, aren't they?
Yeah,
Those
1N5402s, 200 volts at 3 amps.
Right.
You double it up, and assuming the current flows evenly through each diode, then that doubles the current rating to 6 amps.
Okay.
And that was how it was done.
So what have we got next in the circuit?
The smoothing capacitors, these, the 2 blue devices at the top there.
Okay, I'll just show those. So
Yeah.
there, there's big things there. Yeah,
These
okay.
there,
Yeah.
yeah. And they're both 3,300 microfarads at 35 volts. Now I had to replace those because the originals had failed. They started to leak electrolyte over the board.
How would you know that, Tony? Is it just visible that you can see stuff leaking out of them?
You can physically see it. If you don't see it, it doesn't mean to say they're okay.
Right.
But if you can see,
But if there is a
electrolyte-
sign of something coming out of these things that you don't think should be there, there's a
Then
good chance there's something wrong with them.
you don't need to go any further because that tells you they've got to be replaced.
Right.
So,
Okay.
2 of those, I replaced them when I repaired this. Tucked down there, I don't know if you'll be able to see it or not, there's another, it's very difficult to see.
Probably
actually.
difficult to get to that one, I think.
Anyway, under there, there's a transistor in what's called a TO220 package.
Yeah, I can see that. If you hold that still for a second, I can just see the heat sink there, that metal bit in the middle
Yeah.
of your screens now.
And that is the driver transistor for the larger one on the outside that I've got my thumb on here.
Okay, so can we look at that on the circuit here?
Yeah.
Just to sort of relate it to people.
Yeah,
so
of course,
if you've done, I think particularly if you've done your intermediate course, you'll probably understand the basic building blocks here. So we've got our 2 capacitors there. They're in parallel to give us an extra smoothing, aren't
That's
they?
it, yeah. In
Okay.
parallel, so you've got a total of 6,600 microfarads at 35 volts, and you get...
I'm going to ask what people might think at home now.
Yeah.
Why are they rated at 35 volts if we've only got a 12 or 13.8 volt power supply?
Because the regulated voltage across here is much higher than 13.8. It's actually, and you'll see this in a moment, it's about 26 volts DC
Wow.
across there.
So even the 25 volt wouldn't have been enough.
No,
Right.
no, that's right.
Okay.
Personally, I like to be a bit over generous. I used on this what the junk box was able to provide,
Yeah. Okay.
as we usually do.
Yeah. Sure.
And the DC voltage across here is about 26 volts, and that feeds to the 1.8k resistor, that large black device on the schematic there, to the 15 volt Zener Diode. For the benefit of those who are not sure what a Zener is, and some of the newer
The
members,
foundation licensee,
Found-
maybe.
that's
Yeah.
the word I was looking for. The
Yeah,
foundation
sure.
licensees may not be sure. Well, what that will do is connected onto the circuit, as you see it here, with a current limiting resistor. And as the voltage comes up above 15 volts, it will start to conduct. And the idea being it will hold a stable 15 volts on this line here.
Right.
There's a capacitor which is tucked underneath in the bottom here for smoothing that. And you then, of course, get 15 volts up here on the base of this transistor, which is, as I've written on there, is a tip 131. A tip 31, I beg your pardon.
31. Yeah. So that's that driver transistor you talked about. So
Yeah.
so is it right to think this one then is taking some of that power and amplifying it, and then it's feeding that into another transistor?
That's exactly what's happening. And because you get a 0.6 volt approximately volt drop across the base emitter junction, this is a base terminal, that's the emitter, you then get 15 minus 0.6, which is about 14.4 appear here, and that in turn feeds the big transistor, which is
That big old transistor there.
this device,
Yeah.
which is a 2 in 305.5, probably one of the most famous power transistors of all time.
I remember making disc amplifiers with those in my youth. It was a very noisy transistor, but very cheap.
Yeah, that's
And
right.
about 30 amps, wasn't it, capable of, or something like
15 amps
Was it?
at 60 volts, providing you don't exceed the power dissipation of 115 watts.
that? And again, for people at home watching who are not sure about the electronics, the dissipation means the amount of, obviously the unused energy that this is going to, that this has got to drop, it's dissipated in heat, because as you know from basic physics, you can't destroy energy, isn't it?
That's
So
right,
if
yeah.
you're trying to reduce the voltage coming out, that power, the voltage and current has got to go somewhere, and in one of these sort of circuits, it's going to go in heat.
Yeah, and the
Yeah.
voltage, the power dissipation, is the product of the current being drawn by the external load and the voltage difference between the collector and the emitter. So, as I said, there's about 26 volts across there. So we regulate that down to 13.8. Without doing too complex maths in my head, that makes it about 12 volts or so across the transistor. So if you draw 2 amps off there, then that's 24 watts being dissipated.
Yeah,
in
12
the
times, because it's 12
yeah,
times V
because
times A.
watts
Yeah.
is volts times amps.
Yeah.
So the power dissipation in watts is about 24 volts if the load was about 2 amps, and the voltage difference across there is about 12 volts.
Yeah.
And
I guess
That's-
I guess some people watching now, and
Yeah.
just let's go into a little bit of the electronics of it, Tony.
Yeah.
They may ask, well, our mains most people accept is a fairly constant voltage coming in. So why don't they just make transformers that are more accurate, so that they're giving out more or less the right voltage? Is that just not possible to do?
it's not easy to do. If you've tried measuring the mains voltage at different times of the day, I've had to do it at work before I retired, and it can be higher in the evenings in
Oh, really?
industry. Yeah, well, it varies from different times
Yes.
of the day, you know.
Okay.
I found it sometimes higher in the evenings if I was working shifts, maybe because a lot of places are closed down for
Close
the
down,
evening.
yes. Yeah. And the voltage drop, of course, across wires that are going
Yeah.
over their place.
So if
Yeah.
the voltage across here is, say, instead of being 240 volts,
Yeah.
is just for argument's sake 250,
Yes.
then the voltage that appears here
Yes.
is higher.
Because a transformer works with a ratio, doesn't it?
Yeah,
Roughly.
if there's,
So.
just to make the maths easy, if there's 100 turns on the primary and 10 turns total on the secondary,
Yeah.
the secondary voltage will be 1/10 of the primary.
Right.
So if it's 240 volts across the primary, there's 24 volts
24
across
watts
the
an hour.
secondary.
Yeah, it's a fairly easy thing. Of course, like everything in life, though, it's not perfect,
That's right.
is it? And
No.
this is what's called then a regulated power supply. Unlike some little plug-in transformers in particular, which might say on them 9 volts, but unless it says 9 volts regulated, that voltage could actually vary probably between 9 when on full load to up to say 15 volts or
If
something.
you've, oh yeah. If you
But it's something to be aware of, isn't it, for
Yeah,
amateurs to
that's
just be
right.
careful. If it says 12 volts on it, you need to look for that magic word,
You-
regulated.
you need to measure it and see what it really is, because
Yes.
some of them, all they have, transformer, rectifier,
Yeah.
and it's not always a bridge rectifier, sometimes just a diode in one lead, and the other lead is taken to common and brought out until the output voltage depends on the load.
Yeah.
I've seen that with some of these ones that look like a 13 amp plug.
Yes.
Plug them in, as I said,
Yes.
12 volts on it, you measure it off load and 16,
Could be
17
16,
volts,
16, yes.
easily.
Yeah, absolutely.
And it won't be very smooth either.
Right.
But I'm
Well,
trying to-
it's nice, Tony. So you've taken us through the circuit there
yeah,
of how it works, the basic building block elements, fairly straightforward stuff. How would you go about then finding out what's wrong? So someone hands you one of these. In this case, was it giving out
It
too
was.
high a voltage or nothing?
it was giving nothing at all. The little red LED, which I haven't drawn on the
Sorry
diagram,
about that. Yeah.
is was out, So and I looked and it appeared to be connected to the output, so it indicated to me that there was no output. The last thing you do is plug your radio into it before you've checked it, of course.
Yes, absolutely.
So
Is this a good point? I mean, I hope you don't mind me doing this,
Yeah.
Tony, but I went quickly to our workshop earlier. As people
Yeah.
who've come to Radioactive every year will have seen, I normally try and offer one of these, which is a very cheap multimeter. This is about £6, I think, the last time we did it.
was that all?
It's a very bit, yeah, it's a very basic meter, but it's not bad.
I think
Can I
I've-
just?
I think
sort of-
sorry.
That's all right. It just sort of show people. If I think it's something that I don't know if you'd agree that every radio amateur should have something like
Yeah, I
this.
think so. They're not that expensive
No.
and they're not that difficult to use, and perhaps at some time in the future, maybe when the club gets together again in reality rather than virtually, we can have an evening, even if
Yeah.
we just get round a table and explain to
Have a
people
look at
how
it.
to use them.
Well, we did actually a few weeks ago as well. We had Alan Mulkey from the States actually gave us
Yeah.
a good lecture
right,
on,
yeah,
or good talk rather, on multimeters and oscilloscopes. But this is, I just want to show this to everybody because it's literally certainly under £10.
Yeah.
You can buy them, I'm sure, on the internet, similar sort of
I've
price.
seen them under several different trade names
Yeah.
and several different case colours. So I've got one or two and I think mine is yellow.
Yeah, well, this is
And,
just a rubber. This is
yeah.
actually a
No,
yellow
I mean the
shell
thing
here.
itself.
So
But
this
yeah,
fits
they're,
around
they're
it.
so,
But
they're so cheap, that's unbelievable,
Well,
and they will do the job.
well, if you've got a £500 plus radio and you've got it plugged into a power supply and you're not sure what your power supply is giving out because it's like this power unit that you've got here, where you've got no idea, it's a good sort of insurance policy, isn't it?
That's right. Yeah.
Just to, even if you only learn to use it on basic voltage. But
yeah,
anyway, I just wanted to mention that, Tony, because I think
Yeah.
it's something that every radio amateur literally should have one of those, really.
that's right. If you're not sure how to use it, then
Ask us.
yeah, we'll have an evening and I'll show you all
Yeah,
how to do it. Yeah.
Sure, okay. So let's get back to the power supply
Anyway.
fault. So the light was off, it wasn't giving any voltage out.
Nothing coming out at all. So the first thing I've done, check the secondary voltage on the transformer. That was fine.
Okay, so the voltage, the primary is the one that they're going in, isn't it? The mains.
That's the primary.
Okay.
I don't know if I've got someone who's a little bit sharp, eagle-eyed on this. A little thing I pointed out to David earlier. Obviously, that's the live.
Yeah. Can I turn it round?
Yes, of
Because then
course
I can probably get to it. So if I don't mind, it's all definitely unplug this,
Yeah.
guys, because
And
it
what
is
I'm about
important.
to show you is how I found it. That's clearly the live to the on-off switch to one side of the transformer. And you'll notice there's a fuse on the back.
Let me have a look. Okay, I'll just have a look at the output terminals there.
Yeah.
Yep.
The fuse is on the neutral side.
Wow, that is unusual, and that's how it came, is it?
That is how it came, yeah. If you look, you can see the solder joints haven't been touched. Certainly not by me.
No, so that's not conventional, is it? Normally, you put a switch and you put a fuse on the live side, don't you? Which, of course, is brown, not
I
blue.
left this one like this because I wanted to
Yeah,
show people the sort of
Absolutely.
thing. What I shall do before I use it for anything is change that. Take this out,
Yeah.
and rewire the fuse into the live side where it should be, and just wire the neutral straight onto the this end of the transformer.
Yeah.
And then that'll be a lot better, and also change.
Just going to ask Tammy now. Can you see this all quite clearly, Tammy, or
Yeah.
not? I'm trying to hold it still. Oh, I see. You've used the zoom there to get a better picture of instead of me holding it all the time. That's good. Okay, that's
Yeah.
lovely.
Okay.
Yeah. Oh, that's a good
That's
picture
what
actually.
happens if we, no, you can't see much underneath the
No.
two large capacitors, can you? Okay.
I mean, this. Can I just say? I mean, it does look a bit cheap and nasty, if I can
It
use
is.
that phrase.
It
Would you
is
agree?
Yes, I would agree. It is a bit cheap and nasty. They were used predominantly on CV radios, I think.
And it's 5 amps, isn't it? So it's not too much.
It's reputed to be 5 amps.
Yeah.
How hot it would get if I loaded it to 5 amps for 20 minutes or so, I'm not exactly sure. I haven't tried it.
No.
But I have seen the results of not using the right power supplies for the radio. Somebody who shall remain nameless brought me a radio some time ago. It was about the middle of last year, I believe, during one of the lockdowns. Could I have a look at his radio? Apparently, he used to run it off a 12-volt car battery. There's nothing wrong with that as long as you've got the right fuse in the radio lead. With an automatic charger connected across it. So if the battery voltage dropped below a certain amount, the charger cut in. That was fine until the battery voltage did drop below a certain amount.
Yes.
Then the charger cut in. I don't know what the voltage was across the charger terminals, but smoke started pouring out of the back of the radio, and untold flames started coming out.
Well, I mean, because to charge a battery, you've got to give it more voltage than it's actually got.
That's right.
And nominally, again, just for those watching at home and not sure, wondering why we've got a power supply that actually says 13.8 volts when we usually talk about 12 volts. And that's just the natural chemistry voltage output of a car battery, isn't it?
That's right.
It's just one of those things, the chemistry that makes up the average car battery gives out 13.8.
A friend of mine, he's retired now as well, he used to be an auto electrician who ran his own business, and apparently the charging voltage across most car batteries while the engine was running, and I'm going back into the days of dynamos and going back into the 70s and 80s when he was running his own business, was around about 14.2 volts.
Right, so not much higher than the voltage.
That's right,
so about 0.4 or so charging.
If the alternator was charging the battery.
But if this person's radio blew up, then that must have had a lot more than that, I would assume. The battery wouldn't normally blow up.
I never saw the battery or the charger, so I don't know what the charger was, but I'm told it was automatic, and it would automatically sense the battery voltage and cut in if it got below a certain amount, and because it cut in while he was using the radio.
Goodness me.
And that's what happened. I got to see the radio. He asked me if I'd have a look at it. I opened it up and I'd burnt a hole right through the main PCB near the PA transistors.
Heavens. So was that a write-off, or did you
so I gave it back to him and said, sorry, there's nothing I can do with this.
Yeah.
And he learnt his lesson. He then went out and bought a proper power supply.
Okay.
The other thing is to make sure you use a power supply that's big enough for the job. This is reputedly rated at 5 amps.
Yeah.
If you were using it on a 2-meter rig, let's say it drew about 5 amps on transmit, for argument's sake, then I would wonder how long it would last. I've seen one of these fail in the past, not this one, but I've seen it before with others. And you would not want the pass transistor to go short circuit.
Because that would presumably put all the voltage to the output.
That would put the full 26 volts across your radio, and a perfectly good radio would
yes.
probably be coming my way.
I could see that. I wouldn't want twice as much, would it?
Yeah.
Okay. So, right, we're now going to plug it in.
Yeah, right, so that's plugged in. And what I shall do now, show what happens when the pass transistor goes short circuit. It's not short circuit on this one,
So this is just a warning though to you at home now, be very careful, and if you don't know what you're doing, seriously, this is not the sort of thing to experiment with on mains, when the mains is on especially. But we're just giving you a general sort of feel here.
Right,
so you've got a multimeter there on, I'm going to just put that on there so Tammy can quickly show that picture, so of your multimeter.
I'll show you what I've done in a minute to simulate a pass transistor going short circuit.
Right.
If I can get this to...
So this is going to show us how many volts are coming out basically the transformer with those capacitors if the transistor doesn't work.
There we go.
Wow. Okay, so this is, remind everybody, this is a 13.8 volt power supply, but if that output transistor failed, which you've simulated, that's the voltage you get out.
Yeah, 26
by
volts.
By most ham radios, I think.
Yes, that's right, yeah.
Okay.
Now, right, what I've actually done to this one, if you can show your camera down in the top, you might just be able to see that, yes you can. That wire link is connected between the collector and the emitter of the pass transistor, because I wasn't prepared to blow up a perfectly good 2 and 3 or 5.5 for this one.
Okay.
So, assuming you've got one of these, and you would like to find out what has failed on it, you can do most of the fault finding if all you've got is a multimeter with one of these.
So this is a now on the ohms range, is that right?
Now on the resistance range. OL is when it's open circuit.
Okay, so it's overload or open circuit, yeah.
That's right.
Okay, so we're just going to shorten these together, yeah.
And it just shows the resistance of the leads.
So I'm just going to show that now. So then it comes down to almost zero. It's probably just the resistance of the leads there, isn't it?
That's right, yeah.
Okay.
Right.
Right.
If you want to check the diodes, one thing I will just mention before we start, you can show the camera on the end of my leads. These cheap and cheerful multimeter leads, I bought 10 of them for about a £5. last year sometime. But they come like that. No
Okay.
insulation on them at all.
Right.
So it's very easy when you're diving in a piece of equipment
Oh yeah.
to short the probe
With something else.
onto something inside, and you don't really want to do that.
So what do you do? Wrap some tape or something, or a
So
sleeve?
a heat-shrink sleeving.
Oh yeah. Okay. I'll
Yeah,
close up
no.
of that. Can you see that, Tammy? All right.
It's a bit blurred.
Yeah,
Okay. I think we're
that's better.
probably reaching the limit
Yeah.
of my little handheld camera
Yeah,
here.
yeah,
That's better, isn't it?
okay. Yeah, so I sleeve these with heat shrink sleeving so you don't accidentally touch things if you're diving into a rather crowded PCB.
Okay.
So that's that. Anyway, I put my meter on diode test. Which
If
is
you've
that.
got on a wide shot, Tammy, probably at the moment, so people don't feel too sick at home, because I've got to
Right.
work out what Tony's going to touch. Thanks.
Um,
Okay, yeah, I'll go on the meter then, and if
Yeah,
you can keep the wide shot, Tammy, to
and I'll try and watch the screen while I'm doing this.
okay,
Yeah, that's it. Put the leads across the meter across the diode one way,
okay, you can
and
just
that's
see,
the forward volt drop of the diode, about 0.44 volts.
right,
Turn the diode over,
nothing.
open circuit.
So
This
that's
is how
of
it
course
should be.
how a diode should be, because a
Yeah,
diode is an electronic component that passes current just one way.
In one direction only,
Right,
that's
okay.
correct, yeah.
Okay.
And that was one check I'd done. I checked them.
So what did you do? That was a new one that you've got in your fingers,
This is one I
but
brought
this
from
in the board, they're the four there. So you
Yeah.
can obviously again with the power off.
Oh yeah,
Yeah.
yeah. Clearly with the power off. Once I'd established that the transformer was okay, but there's no output, I thought, well, the rest of the fault finding I can do with the power off.
Power off, yep. So there's
So,
something else to watch for at home.
Out came the plug.
So I guess once your main, you know that the mains is going into the transformer, and maybe can I suggest that you might use your multimeter on an AC range on the output just to see you've got voltage there.
Yeah.
As you say, the rest of it you could do with the power off, which is certainly a lot safer, isn't
I
it?
can demonstrate the
Okay.
checking the transformer secondary.
So okay, well we'll do that now.
I'll go around
Tammy
to
can do a
AC
wide shot
volts.
again on this and
This
show.
particular meter is auto ranging, so but not all of them are. So on the ones
Okay.
that aren't, it's
So we've set it to the AC voltage. Again, if you don't mind me telling everybody at home, if you have got a multimeter and you're not sure how to use it, and obviously at the moment the club's not meeting, so we can't show you. One of the golden rules, this is an automatic ranging one, but the cheap one I showed you earlier, you do have to set the range. If you don't know the voltage that you're measuring, start with the highest voltage and work downwards.
yeah, this particular one ranges. If you check them on AC, there's usually only two, maybe
So one of
more.
those says 200, is it?
That's 750
750,
that
yeah,
one,
okay,
and 200 for that one.
right.
So it'd be good idea to start on 750 if you weren't sure what you're getting. You
Yes.
might be getting more than the secondary voltage should be out there because the primary might be burnt out.
Yeah, sure, okay. But if you've got a bit more money to spend, an automatic one like this means you just tell it what you want to measure, which is,
Yeah.
if you can see there, AC,
Yeah.
bottom left,
Switch on
voltage
again.
AC, that little squiggly line means AC.
Yeah.
And then on the voltage, if I can get rid of that, the glare of the lights, there we've got not much coming out at all, just a few millivolts, which is what
Yeah.
you'd expect, isn't it, when it's just picking up noise, really,
That's
in the room,
right, yeah.
electrical noise.
Yeah.
Okay,
If
so
you
I'm
go across
just going
the
to show...
transformer secondary.
Okay, I'll look at that. And now it's got, wow, 40 volts
Yeah,
AC.
it is rather high, isn't it?
Very high.
But it's biphase. So
Okay, right. Again,
And
you're now
there's the
looking...
centre.
So that was both over both windings, really,
that
wasn't
was
it, kind of?
That
So-
was at both ends of the winding.
Yeah, so if we can just explain to people, and this is like what I'd call a centre tap transformer, is that?
Yeah, that's
when I
correct,
was at
yeah.
college, that's what I was taught. So if I do that
Yeah.
there, so that
Yeah.
there, what Tony, if I zoom right in, you can see that there, the outside two.
That is the centre tap,
Yeah,
and that one are the two ends of the winding.
yes.
The top and bottom ones are the two purple wires,
And there's those three terminals, yeah.
and the centre one is the centre tap.
Yeah.
So if you measure between the centre tap and one end, let's try and bring that-
Again, just watch it, and Tony knows what he's doing, but watch just the back of his fingers there. We're getting near those two terminals, and they are the mains
Incidentally, there's
in.
something else you really should
So,
do.
yes.
If you're wearing a watch,
I could tell
with
you
a-
a story about me working on a car radio once with a metal wrist strap watch like that. But anyway, just be careful, guys.
Yeah.
If you're doing this, you need the power on. Do it
That's
quickly.
another thing that's not very good design. They should be sleeved.
Yeah, they should, yeah.
Anyway.
But I saw your fingers quite near and I thought I'll
Yeah.
point it out to people at home.
Yeah. So between the centre tap on one end and the meter's quite
Yeah,
slightly
so there's the
over. That's
motor.
it.
Oh, that's only 1.4. I think that's probably just a connection thing.
Yeah,
There we go,
something like that.
19.7. It's
So-
going to be roughly half the voltage that you saw over both, wasn't it?
That's right. And if I go over to the other one, it should be about the same.
About the same, yeah.
Yeah. And between the two ends,
Should be double, shouldn't it?
there's the
Yeah.
39 volts we had earlier.
Wow, yeah, that's a
And,
lot of volts.
Yeah. And because there's a biphase rectifier, you will finish with this. So we'll,
Yeah, we're just going to unplug
Take
there,
that.
guys, right? Okay, so it's a bit safer to work on.
yeah. So you'll have just under 20 volts on this pair of diodes on one half cycle of the mains, just under 20 volts on this one on the other half cycle. So you'll actually get about 19 times 1.414.
Right.
So
So
I think we can call
it's
that
got
about
roughly
20%.
30, 20, just under 30, isn't
Yeah.
it? 1.4, 28, something like that.
Yeah, that's right, yeah.
Okay.
Yeah, the capacitors will charge up to the
Well,
peak
that's
and
what,
main
because we
voltage.
saw 28 volts, didn't we? Because we
Yeah.
said that would have
That's
blown
right.
a radio up. Yeah.
That's right, yeah. So when I found that this was okay, the next thing to check is the DC level across the output of the diodes,
Yeah.
and that was missing. So that told me, well, there's only one thing it can be.
The diodes.
That's right.
Yeah.
So to replace them, I noticed that the blue electrolytic capacitors had been leaking,
Yeah.
so I replaced them anyway.
Again, there's a reminder of what they look like. Yep,
Yeah.
there. But you could see that physically on the board, couldn't
Yeah, and you have to get the board out to do all
you? You
this.
can see it's still a bit messy, the board, from that.
That is a bit, yeah.
Yeah.
To get the board out, you have to undo the nuts on the back of these terminals, and then it will come out to the extent of the wiring.
Right. Whoops. Sorry, I've just inadvertently zoomed in there. Sorry about that. Right, okay.
Right.
So what are we going to measure next?
Right.
So now you've established your diodes are faulty. Is it then safe just to immediately replace the diodes and plug it in and see if it works, or do you do a
You
bit more
wouldn't.
analysis?
You wouldn't do too much harm if you just replaced the diodes, providing you didn't have anything connected to the output.
Right. Yeah, of course. Yes.
The worst that's got to happen is if the pass transistor was short circuit, then you would then see the rectified AC, the 26 volt side, connected across there.
Yeah. I just want to get rid of the glare.
And but because you've got to take the board out to replace the diodes, while you've got the board out,
Right.
you might as well check the Zener Diode and that transistor, because they're both on the board.
Now, a Zener diode, though, unlike those other diodes, the rectifier diodes here, the Zener diode is not going to act in the same way, is it, if you put that on a meter? So how do you
No.
test the Zener diode is acting like a
The way
Zener?
I would do it, I've got a variable voltage bench supply, which I have on my bench in the workshop, which will go to 50 volts, adjustable, 0 to 50 volts, a maximum current of about 2 amps.
Right.
What I do is grab a resistor, you have to take an educated guess as to the power rating of the Zener, and that was, I think it was a 400 milliwatt. You can calculate the maximum current through the Zener from the voltage and the power,
Right.
and calculated that.
So a multimeter isn't going to tell you that, is it? A standard multimeter?
No, I done a rough calculation in my head. I can't remember exactly what I used. I probably would have used the same value resistor as what they put on here. And to connect the Zener diode in series with the resistor across the output terminal with your power supply,
Right.
making sure that the cathode of the Zener diode
That's the right way
is
around.
to the positive of the power supply.
Otherwise, you'd only see about 0.6 volt or so, wouldn't
That's right,
you?
yeah.
So, because I'm saying this because if people armed with this little bit of knowledge now and they get a multimeter and set on the maybe the diodes scale or the ohm meter, and they think that a diode will only pass current one way, that of course is the case for a rectifier diode, but
That's
not
right,
the case actually for a Zener,
That's
because
correct,
the
yeah.
opposite way round, it will pass about 0.6 volt, isn't that right? I think.
It will pass current once you reach the Zener voltage.
The
A
Zener,
lot of
yes.
people call it the knee voltage.
Knee
I think.
voltage, yeah.
But once you reach the Zener voltage, it will start to conduct in an effort to keep that 15 volts in this case
Yeah.
at 15 volts.
But of course, I mean, a little multimeter like this little cheap one here that I showed you earlier, these only have a 9-volt battery in them anyway, so they're not going to get 15 volts to be able to test that Zener. So that's why you have to do
Well,
something
what you
a bit
can
like
do,
said.
of course, is connect your multimeter. Once you've connected your Zener, and in this case a 1.8k resistor, across your power supply, if you've got one that will do the job.
Yeah.
If you haven't, come and see me.
Mm-hmm.
And as you turn the voltage up on your power supply, when you reach 15 volts, it shouldn't go any higher.
Yeah. Okay.
It will remain at 15 volts if the Zener's okay.
As you
Unless-
say, it's easier once you've got the board out and you can sort of
It's
do all
100
this
times
safely.
easier, and
Yeah.
you can do that. You can unsolder one end of the Zener diode and then solder wires to the back of the board, or if you want to take the diode right out, well, you can.
Yeah. Okay.
And however, they're not very expensive, so I opted to replace the Zener diode. I went up a little bit on the power supply, on the power rating of the diode. It was a 400 milliwatt one that I took out, and I put a 1.3 watt one in, and upgraded that resistor. I think it was a 1/4 watt. Also, I checked the tip 31 transistor. Well, it wasn't a tip 31, it was something else.
Yeah.
But I knew that a tip 31, being an NPN silicon with, I can't remember what the current rating is, but it's certainly high enough for this application. I then checked it. I'll show you on this 2N tip 3055.
So this is a plastic, what's called a plastic body transistor. It actually has a metal back, but we call it a plastic, don't we?
Yeah.
So you're now going to show us how the transistor, how to test one?
Yeah.
So
Right.
can we just firstly work out which is the base collector and emitter terminals?
I happen to know from past experience that's the base.
Okay.
The centre one is the collector, and the right hand end one is the emitter, and the collector is also connected
To that metal back.
to the tab on the back. That's why you have to use a heatsink.
I'm just going to, can I just share that screen? So,
Yeah.
So if you do that again and connect the middle terminal,
Yeah.
there we go. So it's a short circuit.
Yeah.
And I'll just come back to the unit itself, and then you can see what that is. So
That's
the middle
what-
terminal, and that's of course something to be aware of, isn't it? If you're going to put this on a heatsink, because that means the middle terminal, the collector, in most cases, is going to also be connected to your heatsink or your case or whatever else.
That's right,
Something to
yeah.
bear in mind, isn't it? Like
Yeah.
that one there.
Yeah, this one here, the similar rule applies. The collector is the can of the transistor. So you'll notice there's a micro washer under there.
Yeah, that's the very close.
You
If
can
I
just
can get
see the
that-
white outline of the micro washer there,
There,
insulating this from this.
yes. So the mica washer will conduct the heat, but
Yeah.
not conduct the
And
electricity.
so that you don't short it out on the bolts,
Yeah,
you get one of those, and there's another one at the bottom on the two fixing bolts. So it's bolted firmly to the heatsink, but insulated from it.
So, and if you didn't know this, you might not think. You might just think, "Oh, that's a transistor bolted to a metal heatsink." But as you're
Yeah.
showing, it's not connected actually. And when
Yeah.
you look at the meter,
Yeah,
it's not
so-
connected.
So they're not connected together. They
Yeah.
mustn't be,
Okay.
because otherwise the 26 volts would be shorted to the outer case of the power supply.
Right.
Anyway,
Okay.
that's that bit. Now, these type of transistors, the left-hand terminal as I'm looking at it here is the base, that's the collector, and that's the emitter. And transistor, you can do a simple check. It doesn't check current gain or anything like that, but you can check between base and collector, and that's the forward fault drop across
So
the
it's
base collector.
0.5 of a volt?
0.5 volts, about
Right.
half a volt.
Okay.
And the other way, it's open circuit, of course.
Yeah. So you just switch it round and
Yeah.
let's look at that.
Yeah,
Yep.
that's
okay.
right. And between the base and emitter, you get the same sort of thing. It should also be, yes, it is about half a volt, about 0.5 volts. And the other one, which is quite important, the other check you do is collector to emitter. It should be open circuit both ways,
Yeah.
which that one is. So that's a good
Now,
one.
it's a very crude test, this we should highlight to everybody, but
Yeah.
really, if we go back to the circuit diagram and we see the symbol, what you can really think of that transistor as is a bit like two diodes then. effectively.
Yeah, for the
with
purposes of checking, yeah.
Yeah, with the base at the bottom there, that bottom connection is the base, and that's where the two diodes come into contact with each other. Two ends, if you think of it as a diode, and in one direction they should pass current, or your meter should show conductivity and, or say, half a volt if it's measuring volts drop, and the other side it doesn't. And that's a very quick and easy way of measuring a
what you're
checking
looking
a
for
transistor.
is a total failure of the power supply.
Right.
So you're looking for a junction having gone open circuit,
Yeah.
or
the other
if
way.
you've got 26 volts on here, the most likely scenario would be the collector emitter junction
It's shorted
has
out.
gone short circuit. And
Yes.
I don't know how many times I've seen that one over
Yeah.
the years.
Yes, because semiconductors hate heat, really, don't they? So
That's
if it gets over hot, it can kind of short out. Right.
Yeah. So
Okay.
you check that while you got it off the board. I'll use this one because very conveniently, if you can read this again.
Oh yeah.
Ma-
Awesome. I remember that now. I hadn't seen that for years.
Yeah, the manufacturers have marked which pin is which.
Yes. So E is for emitter
That's right.
and B is base.
The way you tell which is which by looking at it, they're slightly above the centre line. The base is in the terminal on the left.
You can see that there.
If the centre line is where my meter probe is,
Yeah.
the left-hand terminal is the base, the right-hand one's the emitter. And so you can do exactly the same check on a 2N3 or 5.5. We very kind of moved the ruler to do this, and
Okay. So I'll look at the meter.
very slightly
There's
less.
0.46. So that's the voltage drop across one junction,
Yeah.
as we call it.
Swap it round.
Swap it round, and then that way it shouldn't be anything, an overload
That's right.
or
Yeah.
high resistance. Okay.
Same with the base emitter
Same with the base
junction,
emitter.
and that's about the
That's
same sort of volt drop.
0.465, and then the other way round.
If we can get on the terminals.
So this is again showing you how useful
Hold
even a
second.
basic multimeter can be.
You'll be surprised what you can do.
You can do, yeah. So that's
Oh.
checking a transistor.
Yeah.
I should just also point out at this point, we're talking about what is properly called a bipolar transistor, where you've got a base emitter and a collector. A lot of modern electronics now, we use things like field effect transistors or FETs and things, and they're not so easy to measure and check with a
That's right.
with a-
They can
with a
still go
meter,
short
is it?
circuit, so you can connect between the drain and the source
yeah.
and look for a short. And between the gate and I think that's the gate and the drain. I think
Right, yeah.
should be open circuit because there's the only limiting factor on the impedance is the capacitance of the junction.
Yes. You've got to be a bit careful though,
Yeah.
and
You
it's
don't
not quite so
usually
easy.
find them on linear power supply though.
No, I was going to mention linear and switch mode later on. So this is a good point to bring all radio amateurs, I guess. Even if you just started on your journey with an M7 and you won't have covered the electronics level that we're doing here, this is what's called a linear power supply. And what it means basically is that you've got a voltage going in, it's dropped down, and then this, if you want to know the proper name for something, that's called a shunt regulator. And this is a way of shunting that takes the extra power or voltage that it doesn't need and converts it into heat.
Yeah.
Now this is how in the old days, I guess 30 years ago maybe plus, 40 years maybe, that's nearly how all power supplies were pretty much, wasn't it? But they're very inefficient, and because we're in a world where we're trying to be greener and greener, there is now another type of power supply that has kind of taken over from this sort of thing called a switch mode power supply. Now it would be well beyond tonight to even begin to talk about how that works. Although
right, yeah.
it's interesting though, and I don't know if you know this, Tony, but in the new syllabus or newest, fairly recent syllabus of the advanced license in particular, I can't remember if it's in an intermediate, but they now do talk about the theory of a switch mode power supply
Really?
to bring it up to date. Yeah, it's only just in the last couple of years that they've done it.
My personal favourite is linear.
Linear, yeah,
I don't
Yeah.
have a switch mode power supply in my shack. I've got a 40 amp
yes,
13.8 volt linear one.
yeah,
I do have a switch mode one in the workshop. But I
right,
don't use it on air. That's only used for test purposes.
right,
And if I want to test a receiver,
yeah.
as linear power supply, certainly some of them can be a
Rest
little
my
bit.
hand a bit.
Yeah.
Yeah,
Can
I
be a
mean,
bit
I think
noisy.
the other thing I'd point out to everybody at home now as well, it's quite important for you to identify what sort of power supply you have, because if you have a linear one like this, which basically, in general terms, means it's going to be quite heavy, because you're going to have a big transformer, especially if it's rated at 20, 30 amps or something. It's going to be heavy, and it might. That's the way power supplies used to be. That's the sort of thing we're talking about tonight, fixing and fault finding, something like that. However, switch modes, completely different methods of looking at them. And one thing I must say at this point, in terms of danger and safety, is that inside a switch mode, where this as the worst case has got mains voltage at 250 volts AC, it's very common in a switch mode power supply to have much higher voltages, and what's worse, they're normally at DC. So it's not uncommon inside a switch mode power supply. Remember, one that's a bit lighter generally. That's a crude way of telling, but if you've got one of these plug in the wall things that are very, very light nowadays, that's not because they've made transformers light, that's because it's going to be made on switch mode electronics. Be really, really careful, because they are going to be running at typically at least 400 volts, in my experience. You've got 250 volts AC, which for a start they convert into DC, which will give you roughly 1.45 times. So
350,
about 350, 360 volts. And because it's DC, it's even more dangerous. Because as you've probably heard over the years, AC is obviously alternating current, and it's reversing the polarity very quickly. And if you were to touch it by accident, there's a fair chance that your muscles are going to contract and release, and it might well help you release yourself from it. DC is different, and because our bodies and our muscles work on electrical power and a form of DC, if you were to get 400 volts DC in your fingers and hands, not only is it a much higher voltage than 250, but because it's DC, it will tend to contract your muscles, because that's how they work. And that can be really serious. But you can't let go. Yeah. So I'm sorry about this. This isn't. I don't want this to turn into a health and safety talk, but it is a very, very serious point. I would even venture to say I've only tried to fix 2 switch mode power supplies, I think, in my life. They are, I don't want to put you off it, but they are very complicated. And because of the way they work, which is kind of like a feedback system, it's called a closed loop system, they're extremely difficult to fault find, because the thing only works when everything is connected together, and because it's not working, that's the reason you're going to be looking at it, very difficult. I was trying to fix something with my mother's many years ago. I failed miserably. And I was nervous about it just because of the very high voltages, at least 350, 400 volts, sometimes even higher voltages inside those things. So, one more time, very, very careful when you're ever working on anything mains, but especially if it's a switch mode, you need to be very cautious.
Yeah, if you got a switch mode power supply and it's gone faulty, take it somewhere else.
Well, let's take it somewhere else. There we are. That's and that is from an expert, someone who fixes things almost for a living nowadays.
I haven't said that. I have fixed them in the past. The way the primary circuit of them works, the mains is rectified with a bridge rectified, which is where you get the 350 volts from. Smoothed with an electrolytic with a high enough voltage electrolytic capacitor with a high enough voltage rating to withstand the 350 volts, typically 500-600 volts voltage rating, and that feeds into the switch mode transformer, the 350 volts DC, and at the other end of the transformer there's a transistor, and that's switched very rapidly, trying to keep it simple, by the electronics, which is further downstream. I call them things 20 milliseconds from disaster. 20 milliseconds being the periodic time, 50 hertz.
50 hertz, yeah.
So
it is. It just is. I don't think we should keep labouring the point, but switch modes are not really suitable. Tammy, we're going back to you, I think.
Yeah, I've got a few comments.
Oh, I've got a few comments. I was going to say, and I probably haven't said it yet so far, if you have questions or comments for Tony or me, but Tony's the expert here, then please ask away on Facebook. So Tammy, give us me a little break, and I can have a quick swig of drink as well.
Yeah, I've just got a few comments. One that's just come in is from Robert G8SDU. He says the typical volts is 400 volts.
Okay,
I think
that's
he's
what
talking
I
about
thought.
what you're
last
talking
time
about.
measured that was about 360.
Well, it's a lot.
With Bob.
It's just a lot. No.
Ian Liston Smith says this was a little while ago. A fine basic little PSU, that's what you've got on the bench there. I put 47 NF across the diodes and electrolytics to decouple any RF that might get in and
Yeah,
cause
that's-
common mode hum, especially on simple direct conversion receivers.
Yeah.
Okay, so Tony, do you want to explain that? So firstly, just to come to the basics of a capacitor, 47 NF is a value. NF stands for nanofarad.
Yeah, that's right.
Farad, of course, being a unit of a capacitance. Why would you do that, Tony? Any comments on that?
I've seen that quite a bit often on bridge rectifiers.
I
That's
see.
all right, I'll
Right,
do
yeah,
it like
okay.
this. I've seen that quite a lot on bridge rectifiers. I'll let you explain the reason they're there.
What, the capacitors?
Yeah.
I'm not sure. Actually, I mean,
No, I'm not 100% sure.
Well, Ian, I see. I thought you were testing me.
No.
Ian actually gave us the reason. I think he said that particularly in direct conversion transceivers. Tammy, did he say?
I've seen them on all kinds of things.
Right.
Connected across bridge rectifiers, 1, 2, 3, 4.
Four,
like
yeah.
that. I've seen them like that as well.
Can you remind us what he said?
He
Ian
said, where is it? I put 47 NF across the diodes and electrolytics to decouple any RF that might get in and
Yeah,
cause
of course
common
it is,
mode
yeah.
hum,
Okay.
especially on simple direct conversion
Any RF
receivers.
that finds its way back into the power supply, there won't be any RF generated in a linear supply.
No.
There might
But
be
this
in a
kind of
system.
decouples it from
And
getting
and
in.
it would decouple the any RF that does find its way back, which it shouldn't, but it may do. It would decouple it so it doesn't affect the output voltage of the power supply.
Yes. Capacitors are only going to pass
yeah.
AC, which can be an RF in this case, radio frequency,
Yeah.
and not the DC.
You
Any
don't-
other comments, Tammy? Have you got
Yeah, Stuart Brooks, he's put 3 comments on. He put 32 volts, Tony. I'm not quite sure what that was in reference to. And he said, oh, hang on, it keeps flipping out. And I told him to turn the radio off. The radio was still working when I told the person to turn the radio off with the flames coming out the back of the radio. I think
Yes,
that
I
was
remember.
what you were
I
talking
think it was
about.
Stuart Brooks who was involved in that one. It wasn't Stuart who
Right.
blew the radio up.
No.
Yeah.
I know that for a
Goodness
fact.
me.
So before anyone
I
asked
think
whether it was,
they're lucky
no,
that it was
wasn't.
still working at 32 volts and it was meant for 12. I think that's pretty lucky.
I didn't actually see the battery or the charger,
No.
so I don't know what the voltage was until Stuart now said, but it's fairly obvious that it was a lot higher than what it should have been.
Sure.
I did see the radio. I got asked to repair it and I had to give it back to the guy and say sorry.
It's only no good, yeah. Any other comments?
Yeah, I've got
Tammy?
3 more comments.
Okay.
Bob Fuller, he says, is he going to dissipate the capacitors?
Okay. Yeah.
Yes, you
When
would.
you switch them off. So you want to
Yeah.
explain what that is, Tony?
Yeah. Right,
So let's have a look at a capacitor on its raw state.
brought one with
If
me.
you hold that down on there, and I'll try and get it on still frame. Okay, so that's a biggish capacitor. That's rated at 2,200 microfarad,
At 50 volts.
50 volts.
I
Yeah.
brought,
Okay.
I brought it with me so you can show a very crude check
Yeah.
on whether it's okay or not. It is a crude check, it's not foolproof.
Mhm.
In the case of this one, the capacitors will have discharged in here by now because the LED will discharge.
Right. Because this is what Bob was asking. Dissipate. It's a nice full technical phrase for it, but
Yeah.
what we're really saying is that when you've switched off these, and I'm sure we've all had a power supply where you've unplugged it from the mains, and we still see lights light up. The
Oh,
mains.
yeah.
And that's because capacitors obviously hold a charge,
What
don't they?
they very often do
Yeah.
is connect the resistor across them, something like
Right.
maybe 1 kilo ohm or something like
Yeah.
that, so it doesn't have any effect on the normal operation.
Yes.
But when you switch off, it will self-discharge.
Yeah.
And you see that they're not put on this one because this is,
This
as
is
I said,
made to the cheapest way, really, isn't it?
cheap and cheerful thing,
Yeah.
probably made in a very well-known Asian country.
Well, maybe.
Yeah, maybe.
Yeah, I mean, it's important, and the reason I think Bob's brought it up is because although you can see here we've got the mains plug unplugged, you think that's quite safe to work on. Of course, those capacitors, especially if there's nothing plugged into it, could well be charged up to pretty much what they were for some time, even overnight
It
almost.
doesn't stop there. If,
Yeah.
like me, you've got a passion for valve equipment,
Mhm.
the power supply in something like an old Eddystone receiver, which I've got several of in my shack, the HT voltage will be something like 250 volts DC, very approximately.
And you'll have a capacitor at that
There
voltage?
will be usually a valve rectifier,
Right.
and again that's usually by phase,
Yeah.
a valve version of the diodes. And the cathode, the valve would come out, if we were looking at this diagram, would come out where the plus 26 volts is,
Yes.
except it would be about 250 volts.
Yeah.
And the smoothing capacitor has to be rated for that. And the voltage across the capacitor would be something like 250 volts.
Yeah.
And when you switch off, that takes several minutes for it to
Absolutely.
discharge through the
Yeah,
rest
and
of the radio.
even longer. So I think what the point Bob's made is really good. A reminder to us that even with the mains unplugged, it does save you from getting an electric shock from the mains, but it doesn't mean necessarily that there aren't voltages inside the piece of equipment.
But you usually find, for that reason, a resistor connected across the terminals of the capacitor.
But if not, in a cheaper power supply like this, get a resistor, maybe 1K, something like that, you reckon? Put it over. It's definitely not a good idea, is it, Tony, to short it out, is it?
No, you don't want to do
But
that.
I mean, some people do it for speed.
What I usually do is monitor the output voltage.
Right.
When you're switched off, go and have a cup of tea.
But of course,
and come
to
back
play
10
devil's
minutes later.
advocate with you a little bit, though, this power supply doesn't work. Or didn't when you got it.
It didn't
So,
when I got it, no.
so it had nothing coming out of it.
That's right.
And if you're working on that, in fact, from what you said, these capacitors might well be working because the power problem might have been with the transistor, and they could be at high voltage. So this is really good advice, isn't it?
It's the
Just
base
to-
emitter junction resultant circuit on the pass transistor. You probably won't get any output voltage
No,
because there's no base drive.
no. So something like a 1K resistor or something like that isn't a bad idea if you've got big beefy capacitors in there and you've got your multimeter. Remember that wonderful bit of kit that you can have. It's really worthwhile. And if you detect that you've got lots of volts on your capacitors, you could discharge them safely with something like a 1K resistor, and you can watch the voltages collapse then. So thanks, Bob, for that comment. And Tammy, and more comments?
Yeah, Ian just came back and says electrolytic caps are not good at decoupling RF.
Right, of course,
No.
yeah.
You will. I don't know what's been done on this schematic. Yeah, there's the capacitors that he was talking about.
Right.
A different value.
Well, we'll have a
same
look at
value.
those in a little while. Shall we?
And electrolytics are.
Yeah.
Can
Well, I could, but I just
Yeah,
think we
hang
should
on
finish this one first.
Yeah,
That's
sure.
all.
Yeah,
Because we're
okay.
talking about a basic power supply. That's
I've
right. So
just
thank
got
you,
a-
Ian.
What you
We
Got
often
another couple as
find.
well.
Well, we've got another comment as well from
Another couple of comments.
Okay.
Yeah, go on.
Roger, G3LDI says, if you think 400 volts is high, you should try 3,500 at 0.5 amp. It hurts.
Does that mean he's had personal experience?
I should think so.
3,500 volts at half an amp?
A valve linear amplifier.
Oh,
it sounds like.
you've got a cat's lives, I think, Roger. Yes, that sounds...
Robert G8SDU says that SW mode caps can hold for days at high volts.
Yeah.
I can remember when I was a student, which was a lot of years ago, they used to have these paper dielectric capacitors at the City College, and I wouldn't dream of doing this now.
Is this a good idea to say this or not?
Oh yeah, I'll go ahead and say
Okay.
it. The sort of thing we used to do was charge them up on a mega,
Yeah.
which generates either 500 volts or 1,000 volts, depending on the model of the mega, and then put them away in the cupboard like it. And they'll be in there 2-3 days, and they'll still be 2-3 days later, still be suffering over
Several
400
hundred
volts on them.
Yeah.
And someone would take them out of the cupboard, they happen to touch the terminals on the top and throw it across the lab.
Well, can I just say, don't do this at home.
I wouldn't dream of doing that.
But
now,
I don't
but
want anybody at home
sort
to
of
do it
stupid
either.
thing you
so-
do when you're a student.
But it is a good reminder. I think it was Bob who said about the capacitors, just to
Yeah.
discharge them. It's a very good point.
Yeah, electrolytics don't seem to hold the charge for long. They do tend to leak. But as I say, the paper dielectric ones that we used to have, which was metal can, and the dielectric in the capacitor, that's the insulating material between the capacitor plates, as paper, and they will hold the charge for days on end.
Yeah, absolutely.
I've seen them used as screen grid decoupling and valve amplifiers.
Okay. So, have we nearly finished diagnosing this? Oh, Tammy's
I
got
just
another
got
point?
one more comment
Okay. Yeah,
go on
before
then.
we go away. It's from Paul, G3VPT, and he says, excellent talk, Tony. There may be a risk of shorting out to something with your metal watch strap. This was when you took your watch off
Right.
earlier.
That's
He said, I
why
had a
I took
mate
my
in the
watch
motor trade who saw an engineer short out his strap to 12 volts, and it melted the strap.
That's what I did. I ended up with a I had ended up. So when I was a teenager, I was fitting a car radio. In those days, cars weren't supplied with car radios automatically, and I found I could earn a few quid by fitting car radios for people. And I was up underneath, can't remember what the car was, but I had a metal watch strap just like Tony's, and I was underneath, and basically got one end of the strap touching on the side of the car, and the other side was on the 12-volt feed, which of course there's quite a lot of amps there. And it just, and basically, I scorched and had a really bad burns on my wrist. So
when I was an apprentice, I used to work at Lawrence Scott's in them days. This is going back into the early 1970s, and I was told a story of where somebody done a similar thing. I don't know whether it was a watch strap or a bracelet or a ring or what it was, but he done a similar thing and shorted it across 400 volts DC.
Oof.
And the supplies they had at Lawrence Scott's in them days were designed to run 800 horsepower motors, so it's 400 volts at several hundred amps.
Yes.
And I think it was a watch or something, because that was his wrist he burnt.
Yeah,
And
that's what I did exactly. It was horrible.
And
that was a 12 volt, so yeah, absolutely. So all these things, guys, we are trying to educate here. We're trying to give you some entertainment a little bit as well, but we're certainly trying to educate you and teach you. But as with all these things, sometimes a little knowledge can be dangerous. So if you're not sure what you're doing, especially with high voltages, mains, or anything like that, you know, the first time you have a go at one, have someone with you who knows something about it. Maybe Tony would be willing to. I would be certainly willing to. Just to help you with
we
this
could
stuff.
be working on something like a TS830, which is what I'm using in the shack at the moment, or FT902 or something like that, and they use a pair of 6146Bs in the PA, in the transmitted power amplifier. The top cap connector on a 6146 is the anode, and it will have a little under 800 volts on it.
Yeah.
And if you're working, you've got your watch on, you do not want to touch the top cap of one of them.
No. So I think it was Bob, did you say, mention about the watch? Tammy, whoever
it was
said
Paul.
about Paul,
Said
good
it.
advice. Take that off before you work on it.
That's why I took that
Or use a
one.
plastic strap, I guess, another way.
That's
So
no-
have we pretty much sorted this pass by now, Tony, do you think?
Yeah, I can cover a bridge rectifier and capacitor if you like. or if
Well,
you
yes, sure, yeah.
Yeah, we'll
So
take
we've
we'll
talked about the
take that one.
capacitor.
Right, so go back to diode function on here.
So you're going back to
There
the
we go.
diode function on the meter. Where are we?
Yep.
Here we are.
Yeah,
There we are.
a bridge rectifier, that's one of these ones.
So a bridge. Now, I'm just going to show us.
I've
Actually,
got
I am
it
going to
now.
just show them a bit of that circuit. That is the circuit diagram, everybody at home, of a bridge rectifier.
Yeah.
It's because there's 4 diodes in it.
Yep.
Yeah.
The way, quite simply, the way it works, on one mains half cycle, the power will go through the diode there,
Yep.
positive output,
Okay.
and return through that one. Beg your pardon,
To give the other side, but that's the other AC feed, isn't it?
Yeah,
That one.
that's right.
Yeah.
Yeah, two
Yeah.
diodes connect on one half cycle, and the other two conduct on the other half
Right.
cycle. That's
So
basically how it
basically, for everybody at home, you put AC in these 2 sides here. I'll try and use my
Yeah.
fingers here to demonstrate that. You put AC in there, and you get DC out here. So you've got the
Full wave
minus and the
rectified
plus, full
DC
wave
out there.
rectified. It won't be smooth, and we'll cover that with the capacitor in a minute with Tony. But this will. So you put AC in those 2 outside terminals
Yeah,
there, and you get DC out. And
yeah.
but this magic box that Tony's got there,
This particular one is 50 amps at 100 volts.
right?
And the way the terminals are configured, that's the positive.
Mhm.
You can see it's mapped to there.
Yeah.
Diametrically opposite is a negative.
Mhm.
And the 2 AC ones are that one and the one diametrically opposite there. So all you've got to do is just go all the way around the edge, checking each diode.
Each diode, yeah. So inside there's some potting compound in there, isn't there?
Yeah,
And what's
that's right.
inside there really are 4 separate diodes
That's right.
that they've
yeah.
just manufactured in the factory and put them all in one little neat package.
Yeah. So
I'll
you
just
can
try
see-
and show you the where's the meter? Here we go. There.
Yeah. So that's that one there. This one will be about the same sort of voltage.
Yeah, that might be the other way around though. So
Yeah,
Tony's
that is,
now just so I can't show both at once, unfortunately. But I'll try and go back a bit and show so you can
That's
see.
it, yeah.
There we are. Maybe
Yeah,
you can
there
see
we
now
are, yeah.
what you're doing. Or
Yeah.
you got that right, Tammy?
Yeah. And that's the other way. It's open circuit, of course.
You see, I'm not a drinking man. Otherwise, I wouldn't be able to hold a camera this still.
And
Except
that's
coffee,
open circuit
not
one
tea.
way.
Yeah.
And
That's
coming
conducting there.
and so on all the way around. So you just
Yeah.
check each diode individually.
So that's an easy way of detecting checking a bridge rectifier then.
Yeah, and you're looking for the same thing as when I done this earlier, either open circuit or short circuit.
With a single diode, yes.
I have seen them fail, not on a amateur radio power supply, but I've seen them in industry where they only fail under load. So you do this checking.
Oh, right.
That's not foolproof.
Yes.
I only found it, but I was on a machine at work. It took us ages to find out what was happening.
Yes.
As you put more and more load on the power supply, which was a 24 volt supply,
Yeah.
the voltage gradually dropped off until the machine didn't like it anymore and shut down. And it took us a while, and in the finish I connected the oscilloscope across a 24 volt output, and then I could see what was happening.
Right.
You look at the
waveform.
waveform, and I think this was 3-phase, so it was every third one, I think,
Right. Just didn't.
gradually dropped off as the load increased, and of course I knew what it was then.
Yeah.
And we changed the rectifier, cured the problem. So they can fail under load only, but that's a quick check.
Okay.
Capacitor,
Right. So capacitor. Well, can I mention a couple of things here? Very
Yeah.
important.
Yeah.
Capacitor has a polarity if it's one of these. Very, very small value capacitors don't have one, but this has. This is a polarity. Very, very, very important to get that polarity right. Not only will it not work properly if it's the wrong way around, but you might end up with quite a bang and an explosion as well.
I have seen that.
So, for some reason, capacitors generally, this is called an electrolytic capacitor, and their negative lead is marked. I don't know why.
Also, the positive lead is slightly longer.
Well, only when it's new though.
Yeah.
I go through my life, Tony, when I'm doing a bit of teaching on some of our courses and things, with LEDs and capacitors. I don't like telling people about long leads and short leads because if it's been cut off, you don't know where you are. So I tend to prefer personally trusting more. But what's crucial is this is the negative side. So the opposite by default is the positive, and it's really important to get the polarity right, isn't it?
Yeah. What you can do, this is very crude. But
Okay,
it's
I'll start so you hopefully can watch the meter now. So is this on again on diode setting? So we can see the voltage going up, because is that gradually now charging up the
It's charging up
capacitor?
the capacitor, and eventually that'll go to open circuit if I left it on there long enough.
Yeah. Well, it'll become saturated probably, won't it? There we
Well, it
go.
won't go
Yeah.
completely open circuit because I had hold of the leads, but
Yeah.
yeah, they are. It's gone.
Okay.
I've done it now. It's very crude. They will tell you whether the capacitor is completely open circuit, which does happen.
Yeah. I think the reality, though, isn't it, that if you really suspect the capacitor, especially if it's got horrible gunge coming out of it, and things that probably, for the cost of something like that, maybe 50p, possibly £1 or so, it's worth changing
Just
it if you're in
change it.
doubt, isn't it?
If you're in doubt, the other thing
Yeah.
I've seen happen, can starts to bulge.
Yes.
This one hasn't, of course, because it's new. Because I can finish up with a lovely semi-elliptical shape there.
Yeah.
Or the same thing happens at the bottom,
Underneath, yes.
and that's when electrolyte starts to leak out around the edge, where the edges of the can are crimped over the end cap.
Can I mention at this point something else, that if you've got a very, very old piece of equipment that hasn't been used for a lot of years, I'm talking about maybe 10, 20, certainly years, 30 years, and it's got capacitors in it, although they're polarised when they're manufactured like that, after a very long time, they can lose their polarity. And if you've got a piece of equipment like a power supply, something that hasn't been switched on for 20 or 30 years, you need to be very careful about switching that on, because if you suddenly, this little capacitor's sleeping away and it's gradually lost its polarisation, if you suddenly jolt it with the full amount of power that's meant to go in it, then you may find that your capacitor just goes bang because it's lost its polarisation. And the answer, of course, and I forgot to bring one in here from our lab down there before, it's not something that many of you are probably going to have at home already, but there's a thing called a variac. And what that is it's a variable transformer that allows you to apply mains to something very slowly and gradually build it up. Now, it only works for linear power supplies, doesn't it? Certainly not for switch modes. But it is a way of, if you've got a very old piece of equipment, you don't want to damage it, and you think maybe it's been sitting 20 or 30 years without being plugged in, get hold of somebody with a variac and then gradually give it 20, 30, 40 volts over a period of half an hour or something like that, building the voltage up, and you might well save yourself a lot of damage because the capacitors can probably repolarize themselves. Is that, you don't want to
taking
Yeah.
your words away, but I think that
Yeah,
that is
that's right, yeah.
a worth time, especially as we are in a hobby where equipment often is lying around not doing anything for a long time, and it's quite useful to be able to rejuvenate an old power supply or something like that. Tammy?
We've just got a comment from Steve, G0MQG. He says the reason we put capacitors across individual diodes in a bridge rectifier is simply to reduce spikes.
Okay. Well, the next thing we're going to look... Have we covered this now, do you
I
think,
we-
Tony?
I think we-
This power supply. So we've
Yeah,
covered a
I agree,
basic
mate.
power supply. Now we're going to look at something rather more sophisticated. I think when Tony shows it to you, are you going to use your other one, your Manson one, yeah?
I can do.
I think probably that's the one, because we're also getting on time-wise. Not that we've got a particular time limit, but this is the power supply that Tony's brought to show you. Now, I think if I can show the front of it, I don't know if you could just quickly, before you
Sure.
start working on it, I think a lot of you will recognise this, because I've certainly got one like this. It was my first amateur radio power supply. This one's got a make of a model number of EP925, and there's a make of it Manson there. However, I've seen a lot of the other the Moonrakers of this world and the Martin Lynch and putting various brands on this. So I think this manufacturer, I don't know if it is actually
Badge
Manson.
engineering, they call it.
Badge engineering, and I
Yeah.
think they make it probably for lots of people. So this is the reason why Tony's bought this power supply. To sort of thing you might have. Probably best part of £100, I think mine was when I first bought mine.
Well, I bought this one second hand, but to buy it new, yeah.
Yeah, it was about
right,
100 when I bought mine,
Right.
and is obviously a lot more complicated. It is still, though, a linear one, isn't it? It has
Yeah.
still got a transformer as its heart of its
Yeah,
power
except
supply.
it's a bigger transformer.
Yeah.
Also, it's not a biphase rectifier, it's a bridge.
Okay.
Which is why I bought the one why I brought that one.
To have a look at. Okay.
Yeah.
So, what, Tony, take us from this one. Is this actually a genuine one that had a fault?
Yeah, the only fault with this one was the voltage adjustment, which is a little potentiometer on the front here. As you turned it up and down, the volts would jump around all over the place. And on certain positions, that would go up to something like 20 volts. I couldn't connect that to a perfectly good radio like that.
No. So what was this rated at normally? It's got 20 volts there, 0 to 20 volts on this.
The
So
maximum that will reach, I think, is about 16, something
16.
like
But as you said, actually, I'm just reading now. There's a little dial there, and it says 0 to 15, or 3 to 15. Sorry.
Yeah.
So that's its rated voltage.
that. Yeah,
But of course, if something goes wrong with it, as you've shown with the other power supply, the inside the thing can be 20, 30 volts even,
oh yeah.
which could easily take out
I'm
a
not
radio.
sure what the secondary voltage of this one is, but we can check it in a moment.
Right. Oh, you've got a lovely camera shot there from Tammy, so that'll help.
In that case, I'll try and keep it in camera shot.
Yeah. I can then show you some of the close-up things at home. Do ask away at home if you've got questions or things. We'll try and ask Tony. I know a lot of you know quite a lot about this stuff already, but we're also definitely tonight is about showing other people, showing you at home if you don't already know how this sort of thing works and how you could fix it yourself. So ask away.
Right. The DC voltage on this one is
So you've plugged it in, by the way. I must just show you. Plugged it
Yeah.
into the mains here. You can be very careful. You've got your watch off. Good. And that's the bridge rectifier. So what are you measuring there? Because I can't see that one, Tony.
trying to measure the DC output. I would have if I turned it on.
Oh, okay. Shh, they didn't notice. Or a noisy fan.
Yeah, they are a bit noisy. Lots
So-
of people are commenting on
Is that the input from the transformer there
That's
that
the
you're
AC, I
on?
beg your pardon, that's the AC. So, I measure
So
that.
we're on AC there. We're on 18.86 volts, and we're measuring there those two big terminals. And be careful where I put my fingers. But these are the output windings of the transformer, aren't they?
Yeah.
In fact, I'm going to get right underneath, and hopefully with this lovely little camera, I can show you that they're literally coming out of the transformer there.
Yes,
So
you
this
can
one,
just
this
see that,
transformer hasn't got terminals, and the wires, probably literally the copper wires that are part of the windings, are coming out and connected via some crimps.
Yeah, it's
to
fake
there.
connectors, yeah.
So there's
Yeah.
your voltage. So we've
Yeah,
got
you
coming
can
out
do
of
that.
our,
Yeah,
sorry,
let's do it,
Tony,
yeah.
we've got 18. Let's just have a look. 18.86 volts. So roughly nearly 19 volts, basically. Yeah. Okay.
So if we now switch to DC,
right? Now we're going to put that, the other side of...
But the other two terminals of the rectifier, if I can get on them.
Now, interestingly, I think it was Ian who mentioned about the capacitors over the
Yeah, there you go, 24 volts.
24 volts. Now, if you're wondering what this is about and you're not done your intermediate yet and your advanced, we've got 18, or did I say 19 volts going in, but 24 volts coming out. I wasn't quick enough to get to the meter there. Let me just show that, because you may wonder what's going on. Well, that's because when you convert AC into DC using a full wave bridge rectifier, basically you're turning the little bumps up the other way. You're going to get more voltage coming out because there's a simple formula. You might have heard Tony and I mention it earlier on. It's roughly 1.4. Let's get it just down to the simplest of that. So if you've got 10 volts coming into something, and you put it through, 10 volts AC, and you put it into a bridge rectifier, coming out of that bridge rectifier is going to be something like 14 volts or something like that. And that's just the way electric is there. So although you're not going to remember all the formulas in the world, but it's something useful to remember, that converting
You don't need
AC...
to know the theory behind it.
No.
It's basically because the AC mains are sinusoidal,
Yes.
and the relationship between RMS and peak value of a sine wave is 1.414, but you don't really need to know
No,
that.
know that.
I use as a very rough calculation in my head, 1.5.
1.5, exactly.
1.5, that's near enough.
I think you're right, yeah. So 10 volts, roughly speaking, is going to be just under 15 volts coming out. That's something to bear in mind if you're designing a circuit.
Yeah.
Now we can see on that bridge rectifier some of those capacitors that I think Ian mentioned,
Yeah.
and someone else, I think Steve,
yeah.
mentioned
Yeah.
as well, what they're for.
These particular ones are 104, which is 0.1
0.1
microfarad.
microfarad, isn't it? And they're for I think Ian said they were for decoupling, getting the RF out and not letting it conduct. And then Steve said something else, didn't he?
He said,
eliminate spikes.
yeah, reduce spikes. Yeah.
Okay. So against surges and things like
Yeah.
that. Yeah.
Which can happen, particularly if you live near industry.
So we've got a power supply here.
Yeah.
We've got the transformer. We've found out that we've got...
Capacitor is here, and you'll see the 24
Okay,
volts
you're
again
just going to
here.
go through. So we've got the transformer windings here. Going to be careful where I put my fingers. There's the AC going in. We've just checked. We've got the voltage DC coming out as well.
Yeah.
And the DC coming out with these big thick wires, because we're talking about, what, a 25 amp power
This
supply,
is-
something like
yeah,
that?
it's supposed to be 25 amps.
Yeah. And that's going straight to this giant capacitor. Now, this is a big capacitor. Look at this.
I'm not sure
And I
what
can't
it's
remember
made
who said, I think it was Bob, was warning about discharging these things. This is
Yeah.
a very big capacitor here.
Yeah, I'll show you what happened. So I can get on the terminals, and at the same time reach the on-off switch.
Right now,
It doesn't disappear instantly, it takes
no,
time.
I'm just going to have a look at that. Now, what Tony's done is switch the mains off, but as Bob especially pointed out, there we are, look, it's still saying 21.49 volts. And that does mean that if you're working on it, of course 21 volts isn't going to generally hurt you. However, if you were working on circuitry and you were maybe unsoldering something or soldering something, you could at the very least get a very nasty spark or a short circuit. But worse, of course, if you're working on electronics and you think there's no power there, but there is, and you short something out, you could damage the very electronics you're trying to fix.
That's right, yeah.
So I think Bob's advice, really good highlighting. And what you could do, of course, again, looking at what Tony's got, can you just put your terminals back on there? Sorry, Tony. You know, if you got in your little junk box, a 1K, something like that resistor, you could put that over there and safely discharge that capacitor.
Yeah.
It's still sitting at 21.51.
You could solder a 1K resistor across in there. In fact, I might do
Yeah.
it.
To
When I
let
get
it
home.
drop, yeah.
And so then when it'll have no effect on, or virtually no effect on the normal operation of the power supply, but when you switch off, it'll, the 1K resistor will discharge the capacitor. It'll still take time to discharge, though,
Of course, yeah. Yeah,
but
absolutely.
it will discharge. So this one look as though we've got a fairly good capacitor in this
I'm
power
amazed
supply.
at these shots that Tammy's getting here. It's good.
Yeah, it's dropped down to 21.5 volts, so it's not going
Right.
to go any further.
Yeah. No.
Anyway, we shall
Okay.
look.
So we know we're getting AC going into the bridge rectifier. That's converting it to DC. That's going into capacitor. What
Yeah.
next to try?
It would be the transistors. I'm not going to put my meter in there with
No,
the capacitor
not with
still
that on.
charged. But under these,
Let me just try and get under the top of this, Tammy, if I can, if you can see it. Don't damage anything though, Tammy.
Yeah.
So
What
that's
you're
where
look-
your power transistors are, isn't it?
yeah, what you're looking at here is one of those bolted onto the heatsink from the
So
underside.
that's the upside down, right? Okay.
Yeah, so that's all that is. There's two of them there, and there's another deck underneath with two more on.
And these are the things that are going to reduce the voltage, aren't they?
Yeah, that's right. And I've not had to interfere with any of this on this particular one, so I've never taken this heatsink out. Because it was all working okay.
When we looked at the other one, it was really quite simple. There was just a bridge rectifier and capacitors on that circuit board, very little else, and a driver transistor. But now, just to show you all at home there's an awful lot more in this power supply. There's a printed circuit board, and in fact Tony's got the circuit diagram here, so I'll see if I can get it out of the light. If I can just hold that for a second, because I know you've laminated it for good reason, but it's not good for TV. There we are. That's, hopefully you can see that at home. Can you tell me or not?
Yeah.
Reasonably well. If I hold it, try and hold it
Too
still.
bad, yeah.
So that's the sort of power supply. The top left, we've got that bridge rectifier, haven't we? Is that the main one?
That's right, yeah.
So underneath that, you can see a transformer symbol. If I
There's
use my
actually
finger,
two secondaries on
there,
that transformer.
there's the transformer. Yeah.
Feeding a second bridge rectifier, which is feeding all the electronics.
Ah, okay. So that will be a lower power one then, presumably. So there'll be a winding at the bottom, and then you can see there's where my thumb is there. That's a bridge rectifier,
Yeah,
and there's your electronics. Look to the right of my thumb. There's all the electronics that are doing that.
that'll do. Keep the output voltage constant. It provides current limiting through the 0.1 ohm resistors, which you can see on the emitter lead of the power transistors. I think that's 0.1 ohms.
Mm-hmm.
Or,
Well, should I? Do you want me to?
no, near the top of the drawing.
There we are. Oh, there. Yeah.
0.5 ohms.
Yes.
Yeah, and the electronic will send the voltage across there and interpret that as a current drain. And it's not the sort of thing you want to test, but it should provide current limiting, so you can't draw more than a certain amount from the power supply. So it provides some form of short circuit protection.
Yes.
But it's not the sort of thing you want to test really.
It's. I think it's. I mean, you repair many more things than I do. I think that's fairly unusual to see 5 transistors like that in parallel. Is it fairly common to share the power like that? You've got all the bases connected together. That's that bottom bit. And you've got all the collectors to connect together.
24 volts rectified out of here.
Yes.
13.8 volts out. Call it 14. Make the maths simple. So that's 10 volts dropped across the transistor.
Right. Yeah.
If you dissipated that, the power dissipation in one transistor would be 250 watts.
Which is a heck of a lot. Yes.
Which is more than the rating of the transistor.
Absolutely.
Which is why
yes.
they do that.
Yes.
To
spread the load, basically.
To spread the load between the transistors. You can get transistors with a higher current rating than 2N3055. So 2N3055, in my memory serves me correctly, has a current rating of 15 amps.
Yeah.
So if you tried to do it with one transistor, you would exceed the current rating of the transistor.
You'd never dissipate that much heat. I mean, 250 watts.
That's right.
Very, people think about, you have heaters that are
providing
a kilowatt
of heat in the tank, but that's not what you want to do.
not really, no. Okay.
So they do that to share it between several transistors. You would still dissipate 250 watts actually, but it'd be shared between the 5 transistors on the drawing there, TR1, 2, 3, 4 and 5. Which is why I've got a fan on the back. This particular one, there's only 2 problems with this power supply. The voltage adjustment, which I mentioned earlier, and the fan didn't run.
Oh, okay. So was that the fan or what was the problem?
No, the fan was fine. There's a problem, I haven't actually sorted it yet. If you look at how the fan is controlled, there's a bimetal thermistor bolted to the heatsink. So the idea being that will cut the fan in if the temperature gets above a certain amount.
Yeah.
And that's that device there.
All right. Yeah. I'd call that
a simple bimetal switch. That's all they are. And as the temperature of it goes above a certain amount, I'm not sure whether that one's normally closed or normally open, but it changes over anyway and brings the fan in. I think that one's normally open, normally closed actually. I think it opens on rise of temperature.
Yeah. I mean, this is it's fair to say, and you can see at home now, if you're beginning in electronics, this is probably not the sort of thing you're going to start with.
No.
You know, teaching you through the electronics. This chip here is an old classic. I mean, it's fair to say this is quite an old traditional circuit, really.
Yeah.
And this LM723 is a voltage regulated chip that's been around for years and years.
That's right.
But
yeah.
obviously, you need a bit of experience to be able to work out what's not working. Although, if you look at it all, I mean, we can take you through. Look at this in here. This is an LM339. Well, I know is a quarter of a package which has got 4 operational amplifiers. And so if we have a look here, we can see 4.
On that particular one,
Yeah, and this one, if you can see, has got an LED which is marked overload. So I think all of that. Where is my finger? There we are. That's
that's a red LED on the front.
Yeah, and that's all that one does. So I suppose you could do some basic fault finding, and if you found that it wasn't displaying an overload when it was working, you might want to look around this part of the chip or something around here.
Yeah.
But so most circuits, it's fair to say, Tony, just talking generally about electronics, I mean, most circuits, the complex bits of equipment, are actually lots of different things, aren't they? They're normally many little circuits joined together. So although on the face of it, that circuit again, Tammy, if you could show that, looks really complicated. If you break it down into individual things, remember we looked at the power supply here that's making a power supply to power this chip here. That's doing a lot of the clever stuff probably in here, voltage regulating. You've got this one is controlling an overload LED. You've got various other bits and pieces here. If you break them down into smaller chunks, then it's not too bad to fault find things like that. Is that the way you think when you're fixing something?
Only look at the part of the circuit that's relevant to the fault you're trying to find.
Okay. So in this case, it was the voltage control, wasn't it? So where is that on here? We did find that earlier, didn't we?
That's this here, VR3,
Okay.
right in the corner there.
Right. So that's a variable resistor.
It's potentiometer. It feeds back all the way through this line into pin 4 of the LM723. The LM723 will do all the magic stuff and adjust the output voltage accordingly to what you've set on the control.
And as often is the way with a bit of equipment, if this has stopped working and it's a fairly old, then I guess the thing to look at would be of the variable bit, the mechanical bit, because that's the bit that's going to be maybe worn or dirty, isn't
What
it?
you do sometimes find, I mean, I was lucky I found that one on the internet, of course.
Yeah.
If you cannot find the circuit diagram and you've got to work blind, the next best thing is a data sheet on the LM723.
Yeah.
That helps. It's not ideal, but if that's all you got, then you can use the data sheet on the LM723, and once you've got that and you know what all the different pins do, you can sometimes work out how it all works if the problem you've got is lack of drive to TR6.
Yes, which is there.
Which is the one that drives the output transistors.
Yep, there.
If the problem you've got is the output is all of a sudden, instead of being 13.8 volts or whatever you've set it to, now about 24, then you're not looking at the this bit, you're looking at one of these pass transistors has failed.
Yes.
Then all you've got to do is disconnect them one at a time until you find out which one.
Yeah. I'm just trying to show a close-up here, actually, of the potentiometer that you changed, which is the variable resistor. They're both the same. Yeah, so if you can just see in there, you can see, I think, with the original control, it is switched off, isn't it? Yeah, because I've got my fingers quite near the things now. Yep. I mean, you can have a look there. You can see where you've removed probably what the original potentiometer.
The original was soldered to the PCB, but I couldn't get one with that board pattern.
No.
With that pin pattern on the back, so I just fitted a conventional one and brought 2 leads out. 2 of the relevant connections on the control PCB, and that worked fine.
Yeah.
But I had to change it because as you adjust this, the volts jumped around, went everywhere.
Yes.
There was a position where it was about 20 volts.
So that was a good indication then, if it was mechanical as you adjusted it, that it could be that.
Yeah, it works fine now.
Tammy, have you got any other questions or comments at the moment?
No, we haven't right now.
Okay,
No.
good. Well, I mean, we're covering pretty well, how a power supply works. I'm interested to know how you think about when someone gives you something, though, like a power supply to test. And as I said, it is at the beginning, this is something that is going to affect everybody. Everybody's going to need a power supply, probably in their shack. Are there any other things to look for?
The 2 most popular ones is short circuit pass transistors, failure of the bridge rectifier, the smoothing capacitor starting to leak over the PCB.
Does that happen in one of these big ones here?
I've seen it happen, but the particular one in this one is okay.
Mm-hmm.
So that's why it's not been touched, apart from the new soldering here where it done some work on the fan.
Yeah.
They're the most popular ones. The smoothing capacitors can reduce their value. I'm not sure what the value of this one is, I can't read it.
No, I'm just trying to see actually. I can see 35 volts, so that's the voltage, but I can't. I don't know if I can get in close enough here.
I think I had to put the capacitor in with it around the back. It's got to
Yeah,
be
no, I
7,000.
can't see it.
It
It's
says
Rubicon,
4.7 something.
Huh?
It says 3.5V and then 4.7.
Oh yes, 4.7. You're right.
Oh, I
can
think.
just see the 4.7. So that probably
I would guess a
4,700,
4,700 microfarads
Yeah.
at 35 volts.
which you'd need. Yeah.
Yeah, you'd need at least that, yeah. This particular one is okay, but I've seen them reducing value with the effect you get 50 cycle AC superimposed on the 13.8 volt.
You don't want it in radios or
You know,
things.
You
really,
switch a
do you?
radio on and make a buzzing sound, and people you're talking to tell you they can hear 50 hertz mains on,
Yes.
or 60 hertz as in the US. Anyway,
Well, I think we've really done a nice introduction to power supplies and how to sort of
Yeah.
start fault finding them. Have you brought anything else for us to look at tonight? I think you mentioned microphones, didn't you? So
Yeah.
shall I help you move this stuff out of the way?
put this on the floor all the way.
This is where they say, this is where we've got one earlier. We're going to now look at some microphones and some general fault finding techniques for that. If you have any questions or comments, of course, put them either on Facebook or BATC, because we're getting on towards the end of our programme now, really. We've been on for nearly 2 hours, which we're happy to do. Here we have, Tony. But we're going to now look at some microphones.
Oops.
So let's have some comments.
Right. Two things. Let's start with the lead first. Most common thing I see with microphone leads is the lead hanging out of the end of the plug. So you can see the individual conductors hanging out of the back of the grip.
So let's have a look at that. Yeah, so that's one of these rotary sort of, like an 8-pin typically, aren't they?
Yeah.
The microphone leads.
Yeah, that's it. I only brought the back.
I'm
because
sure we're all guilty of that, but of course that means that the cable restraint isn't really doing its job. And
yeah, here's the other bit.
right,
And that particular one's a 5-pin one, but you're more likely to see a 4-pin or an 8-pin, I think.
yeah.
And
So
that's a bit
what's
that
the watchword? If we
within-
see that happening before it fails, I guess, is to
do something
about it. Yes.
before it fails, yeah.
Yeah.
If you pull the leads off, if you pull them all off, you've got to work out what went where. And if that's something like an 8-pin Yaesu one, like this one, you could have, as well as having push to talk and audio, you've also got up-down buttons and a fast scan button. And they all come to pins in there, so you really don't want to.
I tell
get
you
to-
one technique which I don't know will help everybody at home that I use now,
Yeah.
because mobile phones, most of us have one, a smartphone with a camera built in,
Yeah.
and because they're so good, if I'm taking a bit of equipment apart, what I do is suggest people take a picture, and what I often do.
I do it as
Do you
well.
do as well?
Yes,
Yeah.
I do it as
So
well.
so you've
And
got all the
also,
colours.
when I save information on the computer I've got in the shack, I'll generate a file, which I'll call FT1000 or whatever it might be,
Yeah.
and in there will be the instruction manual or the service manual, any other information I can find, and if I've taken pictures of something, I've actually done so because my FT1000 at the minute is a pile of bits and pieces under the bench in my workshop because I've got a PA problem.
Oh, okay.
Before I took the PA board out, I took pictures of it in the radio so I knew what connector went where, what wires went where, and all the rest of it. When I come and put it back together, then I know exactly what goes where, and that was taken to bits in July.
Right.
And you cannot remember what you've done 6
No,
months previous.
absolutely. So
So,
mobile phone,
yes,
if you
I'm
have got a
very
mobile
good at
phone
it.
with a camera built in,
Yeah.
a good thing to
Upload
use.
the
Yeah.
pictures onto a computer and save them as well.
Now, unfortunately, it's a little bit late for this one, isn't it?
Yeah.
Because you can
Well,
now see the wires are
Actually, to
exposed.
be absolutely honest, as I used to say on a very old children's TV program, this is one I done earlier.
Right, okay.
What I want to show you is
Well, that just slips through.
How easy it is to pull that off.
Is that, and those are tightened up and
The
everything?
cord grip is tight.
Yeah, so that's not very good,
So
is it? And that's why they come out,
This
I
is one I
suppose.
done earlier as well. That's how I get around it. Little piece of heat shrink sleeving, shrink it on there. I don't think I've got a small screwdriver with it, but you'll find you can then undo this, slip it on there, and then you can do the cord grip up. And if you heat the heat shrink sleeving up a little bit before you do the cord grip up, I'll do that into the heat shrink without damaging the cable.
Right.
And then it grips
Is
it
that
up.
also, because that looked very glossy, this bit of cable, if I can just show everybody at home that. It looked very slight, it's sort of slippery.
Yeah, that's right.
And I
yeah.
guess putting a bit of heat shrink on as well helps to make it maybe a bit more of a matte finish and maybe doesn't
Yeah.
want to slip out so
Yeah,
easily.
this is one I done a few days ago when just to, so that I could demonstrate the sort of things you find. And where you see the leads hanging out of one of these,
Like that, yes.
rather like that,
Yeah. So
you
that
really
point,
want to do something about it before
Right.
that comes, before the
Right
plug comes
apart.
off the end, where you suddenly find you can't keep the radio up anymore because the PTT lead has come off the terminal inside the plug or whatever.
yeah, okay.
So that's that one. So that's worthwhile doing a little bit of servicing before that. Microphones, right, let's have a microphone insert. That's a dynamic one.
Okay,
do
so
get-
dynamic, just to tell everybody at home, that's
a
a
moving
coil basically,
moving
isn't
coil
it?
one, yeah.
Yeah, so it's moving coil, so that's just almost the opposite of a loudspeaker really, isn't it?
That's it, yeah. They will actually make a noise if you connect a signal generator to them,
Okay.
but that's not what they're designed for, of course.
So this is the sort of thing that you're going to find in maybe a mic, you know, like one of these.
Yeah, that one's got a dynamic
Has
insert
it?
in it.
Yes.
There's Yaesu, that's do not provide, and somewhere here I have got.
Is it this one maybe?
No. Icon, Kenwood. Here it is. Right. Yaesu do not provide 8 volts DC on the microphone socket. Well, they didn't when they done 8-pin. Not on my radio anyway. Can't speak for everyone.
Why would you want 8 volts?
If you were using
Oh,
condenser
right, a
mic,
condenser mic, yeah.
that needs power.
Okay.
So
So this is actually, if I just show you the other side of this. And so basically inside here, if I can just give a little bit of the electronics sort of story of this to everybody at home, is basically a capacitor, isn't it? Essentially you've got a plate that's mounted above another plate, then when this detects sound, which vibrates the air, then the capacitance slightly changes. Normally in these there's a little field effect transistor as well to amplify it.
yeah, that's not open circuit to DC. That
No.
measures about 1.2 kilo.
But then, as you say, these, because they've got a transistor in them, they need a little bit of power. So I guess what you're saying is the earlier Yaesus, they had to use something like this dynamic
Yeah.
microphone
you
insert,
can
which
use
is a coil.
you can use a microphone that's got excuse my voice. You can use a microphone that's got condenser mic insert, and
Yeah,
people do with bass mics like this, but this one's dynamic, as I say.
yeah,
But in that case, if you're using it on a Yaesu rig, you'll need to make sure your microphone's got
some voltage.
yeah, it's got a means of putting a battery.
Or I
in
guess you
somewhere.
could put a little battery in and a resistor yourself, and this is quite easy, isn't it, to
Oh,
bias
yeah,
one of these
yeah,
things?
you can do that.
Okay.
Or just make sure you get a microphone that will take usually a 9-volt battery.
Yeah.
Not always though. Anyway,
So
the
we've got this
dynamic-
moving coil. I'll move this one
Yeah.
out of the way so we don't confuse
yeah,
anybody.
dynamic.
Okay,
mic
so we've
insert.
now got this set
What-
to ohms again, your meter,
Yeah.
right?
And you
I'm
will
just
measure
I'll show you that first. Sorry about the
quite
quick
simply. You
movements.
measure the
at home.
resistance of the coil.
So there we are,
In this
and I'll
case, it's about
move
330
back
ohms.
and we can see that 330 ohms. Is that roughly the sort of thing we'd expect to see?
Varies. I'll show you. I've got all sorts in there.
Well, that
Right.
looks like a really old one.
It is. I'm nearly as old as me. And that one is that.
Okay, well, how many
288
is
ohms.
that? Okay, yeah,
Let me turn the after.
that's lovely. Yes, thanks.
This one,
Got a bit of glare.
look at this one
Okay.
this afternoon. I think this is a lot lower.
So these are all dynamic, and this is one way, I guess, of finding out if they're dynamic, because they'll all have a coil in them, basically.
That's right, yeah, and that one's only
I
41
mean,
ohms.
if this works now, Tony, and you get continuity and you get a resistance, does that mean it should work? Is there anything
Yes, it
else to
should.
go wrong?
It should do. I've known them to generate mechanical noise, so people tell you they can hear background noise on your signal.
Right.
I've known that in the past. But the most common thing I've seen is a moving coil going open circuit.
Why would it fail? Is it because it's been dropped, maybe?
Possibly. Plenty of times of picking this up and putting it down
Yeah.
over a period of time.
Mhm.
Movement of the coil by the diaphragm,
Mhm.
because it must be, if you ever look at the wires in it, I don't know if you can see them. No, not on this one. They are so thin, it's unbelievable.
Yeah. About thickness of a hair, aren't they?
Like
some of the
thickness of
coils?
a human hair.
Yeah.
No, I haven't got one where you can see them.
If we can see anything in here, if I can zoom in. Oh, the wire's just come off this. Sorry
Don't
about
worry
that.
about- don't worry about
I mean, sometimes I've had a look at this. I love fixing things myself, and I just don't know if I can get in close
that.
enough.
Do you ever
there.
watch a repair shop?
Occasionally,
Yeah.
not as often
I
as
should be
I'd like.
watching it tonight when I get home.
Yeah, that's a wonderful thing, isn't it?
Hmm.
No, I can't see any coil there, but sometimes
No.
you will see it.
Look.
I guess underneath this red potting sort of compound there is
Yeah.
probably some.
And what I
The
think
thin
happens
wires.
is the movement of the diaphragm. You must have the windings coming from the coil to the terminals on the outside, and if the coil is moving,
Hmm.
then it's got to move all those wires. And my guess is, and it is only a guess because I haven't actually checked, is they eventually break off where they're soldered to these
Yes.
terminals
It's a sort of
inside
weak
the,
point, isn't it? I
element.
guess.
Because
Yeah.
I've seen quite a few of these where that goes open circuit.
Yes.
I've seen that several times. I haven't got one here. I did have a look, but unfortunately, not thinking I've got to need them, I thought, oh, that's
Well,
not
you throw them away, don't
Yeah,
you? You don't want
sorry, yeah.
things like that hanging around.
Yeah.
What else can we look through in
Right.
microphones then? as
Most
sort of
common
faults?
thing I've seen is, as I said, the lead coming out of there, and the end result is loss of continuity through the lead. And you'll see that I've made these little blocks up. I've made them up from last time I was here, so that you can get to the terminals. I can't remember what this one's wide for, but you can get to the pins and check the continuity of the lead. I'll tell you which one it is in a minute.
So I'm just going to show you a close up of that at home, and now I'm going to come back so
Ah,
you can actually
that's that one.
see
Oh,
the multimeter
Yeah.
reading. So
Yeah.
if I'll try and see all of that. Can I just, do you mind if I move that around a
No,
little
no,
bit, Tony,
no.
so you can see it and everybody at home can see that as well? Then we maybe get the two in shot. There we are.
yeah, where's the one?
I'm not going to get a job as a cameraman on the B very
Nope.
quickly, am I? Thanks, Tammy.
Yeah.
Your vote of confidence. So what are you doing now? You're doing continuity check between...
Yeah,
Oh, I can't quite see that block, can I? Right, there we are.
that's what I was looking for.
Right, so
Right.
show us again.
No, continuity check between the terminal on the PTT switch and pin 1 of that plug. This bit is just something I made to make testing much easier.
Right. Now,
And
now
you
lots
do-
of radios have this sort of circular connector, as I call it,
Yeah.
eight pin. Are they compatible with each other or not?
No.
Or sometimes?
No.
Right.
The three big manufacturers, I haven't looked at everybody.
So we're talking about Kenwood, Yaesu and Icom there?
Yep.
Right.
Icom, Kenwood and Yaesu. I don't know if you can get all of them where you can scan across
Right,
them.
let's have a look.
Right.
Let's see if I can do, without my wife insulting
Yeah.
my camera work. The trouble is the glare. Right, there we
Yeah.
are.
Yeah,
So this is
Icom.
Icom.
Pin 1 is the mic input, the audio.
Mhm.
Pin 2 is plus 8 volts for, as I said earlier, one of these.
For the bias, yep.
Frequency up down, now Icom do it differently to Kenwood and Yaesu. The frequency up down pin is connected to ground through a resistor,
hmm
through two resistors, depending on whether you press the up button or the down button. So
Right.
it's a different value of resistor, and it will scan up if you press one and down if you press the other, of course.
So if I move across to the Kenwood, for example,
The
next to it,
Kenwood one,
that's got a separate
the mic input is still the same,
right.
but pin 2 becomes the push to talk.
Oh,
Pin 3 is up scan, but up scan only.
yeah.
The ground connector is in the middle there. Pin 4 is the down. Pin 5 is plus 8 volts to provide the bias for one of them. That pin is not connected. Pin 7 is a ground for the mic lead. And the reason you have a separate ground is, here it is. One of the leads, I don't know how well you can see this, one of the leads are screened. In this case, I think that's the red one.
Right.
But
And that'll
that's
be for your audio,
That's the
won't it?
one you must use for the audio.
Yeah.
Otherwise,
So
you'll
the
be
mic
right
inputs
maker.
seem to be sort of standardish there, but it worries me a little bit that on this one here, which is the ICOM, you've got 8 volts DC output coming out of the radio here, but on this one, that's the PTT, which is the push to talk, which is going to, in my head,
if you plug
be a
the
short
Kenwood mic,
circuit.
if you plug the Kenwood
Yeah.
mic into an ICOM radio and key that up, you short out
You
that 8
short
volt.
out, exactly.
Yeah.
I've not
It's
seen
the
it quite.
PTT on 99% of radios, but not 100%. PTT goes to ground when you push the
Yeah.
when you push the PTT on the
But
microphone.
that's a disaster, isn't it? Why have they picked the same connector, but
well,
with no
what should have
convention?
happened is the manufacturers should have got their heads together.
They should. Yes.
And Yaesu are different again.
Right. Let's move
Go
along
to
to
Yaesu. Pin 1, these are copied out of service manual. That was copied out of a IC575, that was copied out of a TR751E, and this was copied out of an FT1000. Pin 1 becomes the up scan, pin 2 is ground, pin 3 is
So
the
that's
down
completely
scan,
different, yes.
so it's different again.
I'll try and show that in one sort of shot so you can see. So the watchword is really, if you have an ICOM, say someone gives you, or you buy cheaply at a radio rally, an ICOM mic, but you've got a Yaesu radio, the best thing to do is to look at something like this, look on the web, find a connection list, and I think you already got one. You gave me one last time, and I can always send that to people if they want.
Yeah.
And then rewire it, and don't just plug it in and think, well, I'll see if it works. Because from
Don't
what
do
I
that.
can see here, it's very unlikely to work, and in fact quite likely to damage something, particularly this one with the 8 volt output.
Yeah, that 8 volt supply is only rated at a few milliamps.
And what happens if you did plug a Kenwood mic then into that and you short out, you
I've never
push
tried
your
it, but it
PTT,
look as though you
you short it out.
would short out the internal 8 volt supply in your ICOM rig, and you'll be taking the cover off to find out why the 8 volt supply is missing.
Yes.
And chances are that'll be an all.
So that's, if you've known nothing else tonight, I've learnt something myself as well. I thought that they must be broadly similar, so I thought I'd seen things that some of them will work between them. Maybe that's the modular connector. The watchword, I think, is if you've got an 8-pin connector and you've got a Yaesu, Kenwood or ICOM mic, make sure it only goes with those radios.
Yeah.
Or at the very least, have a look at them and rewire them before you use them as something
One
else.
last thing about mics,
Okay.
I think would be okay.
Oh
for
no,
this.
yeah, of course. Tammy, did you get that caption for us on that
I
address?
did, yeah.
Oh, lovely. I think rather than you do that, Tony,
Yeah.
now, this is what
That's
Tony
it.
recommended.
Yeah, these people, they're also on eBay, and their eBay name is Futping,
Oh.
Papa Hotel Uniform Tango, Papa India November Golf, Futping.
Right.
And why they picked a name like that? I've actually-
PHUTPING, and that's
Yeah,
their
no
eBay
idea.
name. No.
Yeah,
Okay.
and if you look at their website, they will do beer microphone leads. So if you want one like this one, then they do them. Varying numbers, of course. Make sure you get one with
So
enough cords.
when you say lead, though, you were talking about with the plugs and things on them already.
They do
aren't
them
you?
with and without.
Okay, so you can just
So-
buy the cable,
You can buy just the
it's
cable. If that's
broken
all you
somewhere.
want, you can buy them.
right?
Do make sure if you do that, you get one with enough cords in it for what you're trying to do.
Right.
So have a look at your old one, and if it's got 6 scores in it, because I've got a host of other things on it, make sure you get the new one the same, or you'll find you.
So I mean, often the ground they do use as well for one of the terminals, don't they? So they're going to need at least
Yeah.
a five wires, 5 cores plus a ground for that.
Yeah, this particular one I've got here has just got 3 cores and ground.
Okay.
I think that come off an old CV mic.
Right. Yeah.
But yeah, do make sure you get the right one. But you can get them ready-made
Yes.
with the right plug on each end,
Yeah.
and you specify what microphone you got and what radio you got,
Yeah.
and they'll supply you with a lead to use this mic with that radio.
Yeah.
I've actually done it at time. I used a Kenwood mic on a Yaesu radio.
And you're someone like me who likes to make things themselves, but actually
and I've used them myself. I must say, this company, I bought a Kenwood desk mic to a modular connector because it's very hard to make a good connection with a modular. A modular connector is what they sometimes call it, but it's really an RJ45, or to a lot of you, it'll be a network connector, like the sort of thing you put in your router. It's very difficult to make a good solid connection to those, isn't it?
Different ones.
But they do a good job, and I paid about £20 for the lead.
You get RJ11s as well. The
Can you?
16 ones.
Yeah. But I mean, it's a reasonable value, and although it's lovely to make your own things, and we'd always encourage that, wouldn't we?
Yeah.
I think when it comes to mic leads, for the 20 or so pounds I paid for it, I found that was good, and I couldn't source the bits separately.
Yeah.
Tony, it's been a wonderful evening, I think. I mean, it's now nearly 20 to 10, so it's one of the longest running ones we've done. But no, there's nothing wrong with that. I hope you at home, I hope we've still got some viewers.
I'm not doing anything
We're not just talking to ourselves. Have we got any questions, Tammy, just before we finish?
No, we haven't actually.
All right. Okay, hopefully you found it useful at home. If you have, and I know a few weeks ago we had some people suggesting that we did some kind of electronic projects and things like that. Maybe this shows the way. You may need a better cameraman to hold it still, although it's difficult when I don't know what Tony's going to do, so it wasn't really rehearsed.
I'll make you a tripod if you like.
Well, we've got a little tripod, but it didn't really help. But I hope it's been useful to you at home. Tony, I really want to thank you for coming tonight, bringing all this gear, sharing your wisdom and your knowledge. I know you do offer to fix things for people, but it's nice of you to come and share that knowledge and experience.
The only thing I'll say is, give me some ideas for next time.
Yeah, okay.
I know Roger's got to ask me to do it again.
He does, yes. So,
so if there's a particular subject that you want to cover, send me an email. You'll find my email address on qrz.com, so it's no secret.
No.
If someone asks you for it, David,
of course,
feel free
I
to
will
give
pass
it
it
to
on. Yeah. We have got, on my desktop, I'm talking about my Mac or my computer desktop, I have still got those mic lead fact sheets as well. So, and that was from a year ago. So if you've seen these mic things and you'd like some connection details, drop us an email to radio@dcpmicro.com, and I'll be able to email them to you very easily because they're still on my desktop. Which this sort of information is very useful.
If you want these, you can have them, because I just print them out of a manual, which is still on the computer.
Thanks. We'll hang them on here then as well. Tony, thank you ever so much indeed. Before we go, and I've got a script. Tammy's pointing me a script, but I already printed one out, so I've got one here, even though I haven't used it much tonight. I would just like to show you something quickly. If you are, and I know there's quite a few people watching who have done electronics and things like that. I can't really see what that says.
It
Tammy.
says, "Did you read this?"
No, I didn't. Oh no, I didn't. You're right. I'm sorry. I will repeat what that says. Let me just do this, Tony. Tammy's quite right. Even though I print these scripts and write them, I'm not following it myself. We did have a comment from Colin, G000R.
Yeah.
Colin, hello, David. Could Tony suggest a way of loading a power supply after repair to be sure it's okay? I have one here which I've looked at and appears to be okay now, but I'd like to soak test it before using it on expensive radio gear. Any suggestions for a dummy load?
First of all, I hope you're still listening, Colin. I hope I haven't sent you to sleep. The way I do it, I've got some of these big sliding rheostats. I should have brought one with me, but I'm afraid I forgot.
Rheostat, just for everybody watching who doesn't know, a big resistor really, isn't it? A giant.
Yeah, it's a thing about the diameter of your camera,
right,
and about yay long. And I've got 3 of them. One, I think there's 2 ohms at about 15 amps. And I can't remember the values of the other 2. And I use them. What you don't want to do is connect an expensive radio to it and put a load on it by keying the radio.
No.
So I use them. Is Colin still watching? Do you know?
I don't know, because it was an email, I think. Wasn't
It was,
Oh,
and he
right.
sent me a few days ago, and
right.
So I just said I'd read that to you. So if you've got any suggestions of loading, and I guess that's.
Can you do him a favour?
Oh, hang on, no, I have got a thing here. He says, I'm here. Colin is here.
Well, in that case, Colin, I think you know where I live, because I know you don't live too far from me. Pop round, I'll lend you my rheostats.
There we are.
So there's your answer.
Solution. I'm going to have to load up a power supply.
That's how I do it. I've got 3 of them. One has got a maximum current of about 6 amps, and I've got 2 others. One is loads to about 15 amps, and one is a little bit less. I can't remember exactly what. And I connect 2 in parallel and adjust them to load the power supply up, and I can go up to about 20 amps.
All right.
and I can leave it on there for a while. And all that happens is the workshop gets nice and warm.
Okay.
So if you want to borrow Colin, you're more than welcome. You know where I live, or I think you do. If you don't, get my email address off
Get in touch
qrz.com
with us.
and get in touch with me. And
Right.
I'll send you my home address and you can pop round. I'll get her indoors to make a cup of tea.
All right. Thank you very much. There's an offer for you. If you've got any questions or anything for Tony after the show, then obviously you can drop us an email, either direct to him or you can drop it via us, and we'll be happy to send it to you. I do think we need to end there. There's the email address on the bottom of your screen now. Once again, sincere thanks to Tony for giving up a whole evening here tonight. We've all learnt something,
Okay.
all of us. I wouldn't have known what the capacitors were across bridge rectifier, but there we are.
Yeah,
I'm
I
more of a,
wasn't 100%
my
sure,
instructors
to be
when I worked for Pi would call me a DC man because I wasn't into the RF stuff very
honest.
much.
You know
but-
what happens above 50 hertz.
well, exactly. So that was me. But thank you ever so much for tonight.
The only thing before we go off here, Tammy, if anybody out there who's watching, who's not got bored and switched off, if anybody out there is watching, have got any ideas for what they would like me to cover next time, like I say, send me an email. You'll find my email address on qrz.com, and we'll see what we can do.
Yep. Okay, that's good.
So,
Absolutely. Tony will be back
I did
again.
ask that last year, but I didn't actually get a reply.
Well, next year, I think is what we're saying, because we're not far away now. You'll be back again and do something for us again. But thank you once again, Tony. Just to let you know what's happening on the All Club next week. On Sunday, we've got the GB2RS news on GB3MB. On Monday Night Net with John M0VCX and the 80 metre CW net on 3.543 megs at 8:30. And next Wednesday, here on NARC Live, it's the demolition crew behind the scenes. Find out what Sonny and Paul and all of their teammates do when and why indeed they're called the demolition crew. He told me recently why that was. Don't forget to let us have your stories as well and your news as well as always for us on NARC Live and those cards as well. But that's it from quite a long night here. Hope you've enjoyed it. Thank you very much from Tammy M0TC.
Bye-bye.
And from me, David G0MQG, and Tony G0MQG.
Right.
It's good night from us. Bye-bye.
All right.